Hello everyone and welcome to today's session on Tableau Full Course by Intellipaat. Tableau is a powerful and fastest growing data visualization tool used in the business intelligence industry. It helps in simplifying raw data in a very easily understandable format. Tableau helps to create the data that can be understood by professionals at any level in the organization. In this session, you will learn all about Tableau. So without further wait, let's check the agenda for the session.
Hey, hi everyone. Okay, so before starting, I would like to know what is your understanding about data visualization? What is data visualization? Data visualization is the process of converting raw data into easily understandable formats of information that enables us fast and effective decision making. So if you see on the left hand side, so this is the raw data. It's in the form of rows and columns. So what we should do with this data? So basically we can create a various kind of reporting. First of all, to start with in Excel, most of the time we go with the pivot tables and all. And then we convert into the charts or diagrams or pictures. Some of those things actually will help us in understanding more meaningful information. Like for example, in this data, if I want to understand a particular state or how many number of states are there, like, each state, how many customers are there. So a simple bar graph or a simple map will help me in understanding that, right? So you see the data, there's so much data, but the moment you convert into a graph, you can see a lot of things. So what all those things we can see? The benefits. It allows users to view several different perspectives of the same data. I'm using the same data as a developer and I want to understand geographical information analysis. Someone else wants to understand the customer product purchase behavior. So like that, you can use the same data. It allows users to view several different perspectives of the same data. Also, it makes it possible to interpret vast amounts of data. So we have some limitations in the Excel. If you want to create a report, but within the apps, the BI apps today, you can actually interpret vast amounts of data because the data is growing exponentially, right? So today you see, even if I want to check into the social media data, the data is so huge. So these kind of apps will help you to interpret vast amounts of data. It also offers the ability to note exceptions in the data. So exceptions means what? We can see the outliers, anomalies, all this information from the same data, and you can create a multiple reports out of that. Also allows the user to analyze visual patterns. Am I seeing any patterns? As like in a purchase behavior is different, or do I have clusters in my data? So these kind of things you can create. It also allows to explore trends within the database. So am I seeing any seasonality, or is it like no season impact? So these kind of things you can explore in the data. So that's the benefits of data visualization. Today we all speak about big data analytics and all. So in that, one specific part is visual analytics. Visual analytics is a field in information. It focuses more on analytical reasoning and the interactive visual interfaces. So the analytical reasoning is something, once I create my reports, I want to actually explain what happened in the past, why it happened, and what is going to happen. So that is what actually in the data science, right? So we talk about four pillars: descriptive analytics, diagnostic analytics, predictive analytics, and prescriptive analytics. So how do you put it in a more visual way? And once it is done, we want to give that as a interactive experience to the users so that they can also do the interactivity with your reports. Somebody wants to see the report for a period, or somebody wants to understand their city, their region. If someone is in the sales department, if they're in the field sales, if they want to know their region or their city sales. So those kind of interactivity you can provide for the reports. So finally, what is data analytics? It is a process of examining data to identify the patterns. We are doing the discovery, interpreting the data, and communicating the meaningful information to draw conclusions, business decisions. So these business decisions usually we need with the help of a specialized software. That's the where all these visualization softwares are there, be it Tableau, Power BI, Click, Elofin, Sisense, and so on. So like we say, the picture is worth 1,000 words. Why? Because the reason is we grasp the picture more than reading the information or remembering the numbers. Suppose if I actually give a picture of a particular, a lion or a tiger, and then I will tell you the attributes to draw it and understand. So which one is easy for us to identify? It is always a picture, right? So visual representations enhance the human cognitive process. So that is the reason we are moving towards like the visualization reporting, so that it is easy to grasp the numbers, and also you can understand where it is going good, where it is going wrong. So some of the business needs which are fulfilled using these visualizations are they can see more information than a table. So not only in a pivot table or something, they can see more information in the form of graphs, charts, and diagrams, and that too in much smaller place. So today, people can view even in the mobiles also the reports. On the go, they can see the reports. And the data visualization leads to better understanding. They can take quickly business decisions accurately and quickly. So that's the way the Tableau developers will come into the picture, or the BI developer. We provide appealing and dynamic visuals that manipulates and interact directly and easily with the data. Also, we enable automatic updations. We facilitate data analytics and data discovery. We identify trends and patterns from the data so that the businesses can take action on the emerging trends and they can be on top of their game. That is what actually how we address the business needs. Okay, some of the real-time scenarios. So a visualization or the reporting part, we can apply on any of the industry or any of the business line or the service line. For example, here we are talking about the hospital. So for the hospital industry, the data visualization will help in some of the areas, that is, they can replace manual reporting efforts. They can also get real-time insights into their services, whatever the services they offer, and some of the uncovered hospital patterns and trends they can identify. These are few examples, but they can do a lot of things. So the healthcare data has the potential. Every business, your requirement is either you increase the revenues or reduce the cost, right? And finally, that should lead to your customer satisfaction. The same thing for even for the healthcare industry also. It will provide the potential to reduce the cost. They can also enhance the quality of the services. That will help them improving the patient experience. So to do all these things, what is the challenge today? It's always insights and actions. How do we derive those things? And for to do that, we need the data. So that's the way actually what kind of data we are dealing with. Are we dealing with structured data, semi-structured data, or unstructured data? So Tableau is the visualization tool. It empowers everyone, not only the healthcare industry or any other industry or department or a function. They can find the right path forward by analyzing the data and help them in taking the business decisions. Let's see some of the examples how the healthcare industry, that is hospital, creating the reports or a dashboard. So this is called healthcare dashboard. Everybody has the way of understanding the data and your way of interpreting the data, right? So for example, if this is a report, we give it to the healthcare industry, that is a hospital, whoever is asking for it. So the number of records for them is the number of patients walking in. Okay, so this is the hour of arrival. So their patients are walking in every hour. What is the number? And also the hospital has a compliance within the timeline they have to attend to the patient, whether it is, the treatment or something, but they have to attend to the patient. That is over 4 hours, less than 4 hours, data is captured. So this means, suppose if somebody is getting the patient is attended by the doctor, nurse, or whoever is the staff. So that is the less than 4 hours is their compliance. So now you also see some of the hours which are not actually as per the compliance. It's more than 4 hours. So this means they get to know now from 10 o'clock to the 6 o'clock every day. So there is a non-compliance is going on. So for them, this is one action point. Okay, even 0 hour also, but yes, we'll come back to that later. Now, the second thing is there is something called green color. And slowly from 7 o'clock, the green color numbers are increasing, right? So green color is unknown. So this means either the data is not captured or people are not trained enough or the staff is new, they don't understand the process and they're not updating in the system. So this is the way the second action point for them. Do they have to give any training? How to treat this particular issue? So this is for the business. This is a business understanding I'm talking about. So for example, if suppose there is a non-compliance, so this means either you don't have enough manpower to attend to the patients. So that's the way the next data understanding is. First, I need to know the patients who are walking in of coming from what actually purpose, what kind of treatment or what kind of emergency they're working in. So when they provided this information, so this is related to this. So this means their specialty breaches most of the time is for the stroke related things the patients are working in. So their hospital is more of specialty on the stroke, and the rest are equal numbers. So when I have to increase my manpower, the business can actually get an insight out of this. They can plan it more of the stroke related people the doctors or nurses who can attend to the patients. So like that, slowly you'll get into the more data understanding, and then you will write the insights. So this is what your observation. You can say that. And you can say that most of the patients are walking in for the stroke because it shows 50% of the contribution. And you can say the length of the stay, the patient, how long they're staying in your hospital. You have 5 to 5.5 days, 5.5 to 6 days, 6+ days. So most of your patients are actually staying more than 6+ days. So why do we need the LOS? Because they need to plan for the next patient arrival, inpatient arrival. If I don't have beds, so what is the use of actually, taking in a patient? Or you can give only the outpatient services. So they need to get into this kind of information so that they can keep it ready, the information for the next patient. So like that, you can see a lot of data where you can understand. This is called a dashboard. A report means in Tableau, it's a single report. Either it's a breach status by R1 report, reason by reason 1 report, or specialty weight breaches 1 report. So what we are doing, dashboarding means we are bringing all the reports into a single view so that I can interpret the data, I can analyze the data with other reports, and I can also compare the reports. So that is called dashboarding. This is what we are going to do in Tableau. Once we create the reports, we finally provide the dashboard so that people can understand what is going on in a single bird's eye view, we call it, right? That way. Now let's move on to the Tableau. So why do we use Tableau? We always talk about Tableau is, various benefits are there compared to the other BI tools. So let's see what is the Tableau all about. Okay, so let's move on. Let's understand what is Tableau all about. Tableau is an interactive BI tool, software to be specific, used for data visualization and data analytics. You can also do some of the analytics also, but a simple analytics models you can work. It's an American computer software company founded in January 2003 by Chris and the team. They developed this software. So what the Tableau do? You can analyze and transform data into interactive visualizations in a few seconds or minutes. So the right hand side, whatever you're seeing, so this is what actually the Tableau report page looks like. And you can query a range of data, including relational databases. You can connect to the relational databases, OLAP cubes, cloud databases, and spreadsheets to generate a number of graph types. So you have already predefined charts available. That is here on the right hand side you're seeing. You can choose any chart type basis your data, what you want to represent. And you can connect to any of the databases. It can be relational databases, OLAPs, or cloud databases, or flat files, or spreadsheets, and so on. So the power of Tableau, it is an easy to learn and easy to use tool. Out of all the visualization tools, Tableau is the easiest one because you have a drag and drop technology. Anything on this, for example, if I want to bring in a particular report, you just need to drag from here to rows or columns. And it is a user-friendly interface that helps generate visual reports in easy to understand formats. So this encourages business users to create their own reports. Even the business users also can create their own reports. Prashant, you're asking flat files, does it? No. Flat files also you can connect to JSON files, or you can, if you want to connect to spatial files, PDF, CSV, all types of files you can connect. And Tableau stores data in memory. Therefore, the processing speed is much faster than those that store data in the disk. See what happens end of the day, even though you create a beautiful reports or easy to understand formats, always the issue comes with the data part. Data is the major thing. If the data is huge, what happens? The performance of the report will be slower. So Tableau has a in-memory option wherein it stores in the fast data engine. So what you do is in Tableau, there are two types of connections. One is a live and extract. When you connect your databases or any files, it is a live connection. Once you load your data, you move that into the extract mode. The moment you convert into the extract mode, a copy of your data will be created in your local system. So when you retrieve, when you open your workbook, when you refresh it, it picks up from your memory. That is from your system, local system. So that is why the processing speed is much faster. Today, more than 10,000 organizations, so this is very less number, but more than 10,000 organizations using the Tableau, and they're getting the fast results in the office and on the go. We also have another product that is called Tableau Public, same as a Tableau Desktop. A few changes in terms of accessing it. I mean, the features, everything is same, between the Tableau and the Tableau public and the desktop. But public name itself is whatever you create the reports, you need to save it in your login IDs, and that is visible to everybody. So that is the difference between the public and the desktop. So tens of thousands of people use the Tableau public because you can practice it. You have the public data sets that can be provided to everybody. So those things actually you can work with the Tableau public. So you also can actually interact with other Tableau developers and you can work on this. So you can share your data in your blogs or websites. And this is a free tool. Whereas the Tableau desktop, it is a licensed version. Tableau public is lifelong free. Only 3 disadvantages I will explain while we are learning about the Tableau products. Okay. Tableau visualizations are automatically streamlined for mobile devices. That is, you can create the views, enable the views for the tablets, iPads, phones, etc. Thus enabling mobility so that data and reports can be accessed from anywhere at any time. People can view the reports even when they are in the field. They can just download or they can log into their web logins and they can view their reports. So that is the power of Tableau. In a much simpler way, you can do analysis, you can connect to any data sources, you can integrate with your any of your analytical tools and so on. You can connect to the big data, you can interact with people, performance is much faster, it's easy to learn, and then you can view your reports even in the mobile and iPads also. So Tableau versus other vendors, there are a lot of other visualization tools are there. Tableau is always leader along with the Microsoft and Microsoft Power BI and Click. So there are other visualization tools also there, but in the leader segment, always these three are the ones which, this is the Gartner Magic Quadrant wherein, they actually provide the tools and technologies in the market basis the feedback they receive from the clients and the organizations. They do provide the ranking. So that's the way actually, this is the leader section. These three are there. Okay, so then we'll move to the products. Like I said, there are various Tableau products available. So now each one of the product, let's understand what is that actually we do with this. The first one is called Tableau Desktop. So this is the one which we do create the reports or dashboards. So Tableau Desktop will enable you to do the ad hoc analytics, dashboarding, and reports and the graphs. You can explore, visualize, and analyze data in the Tableau Desktop. You can create dashboards to consolidate multiple views. And also we can deliver the interactive data experiences. Now the same thing you can also do in the Tableau Public. Okay, desktop is for the organizations. And this is the licensed software. This user-based license. This is for the organizations. Now Tableau Public, it does the same thing of Tableau Desktop, but whatever you do, you need to share with everybody. It's called Tableau Public. Once you create your reports, you cannot save it in the local system. So that is the difference. Whatever you create the reports, you have to publish. Here you can publish it, you can save it in your local system. Publishing means you have your own servers, organization servers. There you will publish it. But whereas a Tableau Public, you will publish it in the Tableau website, which is a public account. People can view your reports. You cannot put any controls there. And it is a free download and free hosting service. Anybody can view and you can save it for free. You can download this application for free and you can work forever. We also have another two products that is called Tableau Server, Tableau Online. These two are the servers. Tableau Server means this is an on-prem server, on-premise. Tableau Online is, this is a cloud server. Now both features are same. So these servers are required for organizations because once as a developer, you complete your reports in your local system, you need a place to publish it so that the end users, they can view the reports. That is called Tableau Server. So the on-premise server, people can choose on-premise or cloud. So this server is used for on-premise. What it can do, BI solution scales to organizations of all sizes. It share visual analytics with anyone with a web browser. So people, how they can view the reports, they will be provided with the login IDs using for the web browser. So they can log in the web login and they can see the reports, whatever you have created. You can also publish interactive analytics or dashboards. Your data is always secure and you can manage your metadata. Also, you can collaborate with other users, other developers. That is your Tableau server. Now the same thing on the cloud also. Nowadays, people are moving to the cloud because we are all working from home. So this is used for cloud-based deployments and managed and maintained by Tableau company. So save high level of security. You can also publish the same thing, whatever you're doing here, the same thing can be done. It's just that online is managed by Tableau, whereas on-premise is with you as an organization. So there is another product that is called Tableau Reader. If suppose once you create your reports, if you're not publishing it in the server, if you want to send the file to the end user, they need the Tableau Reader to open it. If they have the desktop, that is fine. But if they don't have the desktop license, they can download the Tableau Reader. This is a free download. They can just view the reports or dashboards, whatever you have prepared. Just that they can see only the reports and the dashboard. They cannot create anything. Create means developing the report or just dragging and dropping one report to see. Those things are not possible. Only they can actually see the reports. They can do a little interactivity, that is, they can play with the filters or sorting. So those kind of things they can do. So this is also a free download. So Tableau Reader does not cost any license. So anybody can download. But the limitation of the experience is they can just view the report. That's all. Now the last one, that is called Tableau Prep. So the Tableau Prep is a ETL tool. Recently Tableau launched. So it does all the extract, transformation, and loading of the data. It is used in preparation and modification work on data before creating the dashboards with Tableau Desktop or Public. So this means I can do all my ETL activities in the Tableau Prep, and then we'll move on to we'll connect the final output to the Tableau Desktop, and then we can work on the reports. Of course, there are few things you can do it even in the desktop also, like joins, relationships and all. But those things now you can do it in the Tableau Prep. It's a separate tool and it is a licensed based again. So that's about it. Total, we have 2 products for the creation, 2 products for publishing it in the servers, and one is the reader, another one is the ETL tool. Okay, so how does a Tableau work? Tableau work in 3 simple concepts. You can connect to the Tableau to any data source. Like I said, any relational databases, cloud databases, flat files, or web data sources. You can connect to any data. After the data is connected, you can analyze the data the way you want, such as you can create the reports, you can provide filters, interactivity, you can do the sorting. Also, we can do the aggregations, we can summarize it, we can create the dashboards, and so on. Once your analysis and reporting, everything is ready, dashboarding and all, how do we share it? We can share the results with others by one, you can send a workbook with other Tableau users, or you can also paste the results into the applications such as Microsoft Office. You can put it in, copy paste it in the PowerPoints or Word documents or in the Excel files. Also, you can convert into the PDFs, your reports, final reports or dashboards, you can convert into the PDFs, or finally, you can publish it in your servers, can be on-premise server or cloud servers. And in the Tableau Public, you can even embed in your blogs and websites, your reports. Of course, even desktop also you can do, but public is more of like publicly available data, right? So it is not confidential data. So you can connect to in websites or blogs, you can share your data. So how do we connect the data? So the first step is you have a Tableau icon right now in your systems. So double click on that, it will open. And after that, you click on the Tableau icon on this. This page will open, right-hand side, right? Once you open the Tableau, looks like this app. There is a left-hand side. There's a Tableau icon is there. When you click on that, it will show the data connect part. So when you open it, Tableau application, you will see this is the page it opens. So this is the Tableau icon. When you click on that, you go to the worksheet or go back to the data source here. So this is the connect page. Here you can connect your Tableau server or your files, any type of files you're seeing, right? Excel, text, JSON, Access, PDF, spatial, statistical files. So this is the servers. So now this space is for the servers. You can click on the more. Any type of server, if you have organization, your servers you can connect. Sometimes you need ODBC and JDBC connectors. You can download it and then you can connect your databases. And also you have a sample data sources available that you can see here. Apart from that, if you worked on some other Tableau workbooks, this space is for that. You can see all those things. On the right-hand side, you have a discover option. This is from the Tableau directly. You can see the trainings on how to connect your data for future references. Once your training is over, you can always go back and learn or, refresh your knowledge. You can check this. So these are the resources. Tableau Prep I talked about. You can get the Tableau Prep tool. Tableau Blueprint Assessment. any information you want to understand, you can click on this. You also have the community forums where you can interact with other developers. Anything latest, you all can see the information here. And this is the latest versions. Always it will prop. You can download easily and you can connect. So now it's a 2021.4 available, latest version. You can download and you can use it. So this is about the Tableau. And once you move to this one, there is a page called worksheet. Here is the space you will create your reports by dragging your fields onto the rows and columns. So once you connect your data, you can drag the rows and columns. So this is a report. Next one is the dashboarding. Once your reports are ready, you will see all the sheets, available sheets. So that you can create your dashboards. After that, you have a story. Story is not a compulsory, but you have an option wherein you can bring both the dashboards and the reports onto the story. Okay. So once you complete your reports, you can show individual reports also, not a problem. Or you can bring all that into the dashboarding. You can bring all the reports, or you can create the story by bringing both dashboards and the reports. In Tableau, we can use the filters. There are various types of filters are there. What does the Tableau filter do? Tableau filter changes the content of the data that may enter into the Tableau workbook. Okay, in the workbook or dashboard or view. Tableau has a multiple filter types, and each type is created with a different purpose. So it is important to understand who can change them and the order of each filter is executed. So this is what we are going to learn. And the filter box for the dimension, it looks like this. Let's go and see how many types of filters are there. One is a dimension filter where you will use a dimension on the filter box. One, you have the measure filter. You will use the measure on the filter box. Quick filters are something. This is for the end user. You will enable them so that they can interact with it. Dependent quick filters are something, filter on filter you'll create. So other quick filters that can be quickly multiply and slow down the performance. So the moment you start adding 3, 4, 5 filters, of course, the performance will go slow down. There is another one, user filter. It can be changed by anyone in Tableau Desktop, web edit mode, or regular dashboard mode in a web browser. So while you're publishing it, people can start actually viewing the filters. They can interact. That can be in the desktop, or if they have web logins, or if they have regular Tableau report, they can see, they can change. And you have another two that is called context filter and the data source filter. Context filter is something, it is an independent filter. Whatever you set on top of it, the filters, it will go through this context. So this means I have 4 regions data. In that, I've taken 3 regions. One region I excluded in the filter, and then I'm converting that as a context. So this means now on top of it, if I'm creating any other filter I'm adding on it, it will be applied only on those 3. So that is called your context filter. So the dependent filters, because they process only the data that passes through the context filter. Out of 4 regions, I have only 3 regions I filtered it. On top of it, if you add any filter only on 3 regions, it will work. We'll learn it, don't worry. Okay. So this will help in improving the performance of our reports, because you're not opening it up for all the filters, like, you're passing through the values step-by-step process. Now, the last one is called data source filter. Data source filter is at the data source level itself. Right now, whatever we have seen, right, the list of the filters, those are all at the sheet level we work. Whereas the data source filter, it is at the data source page. This is also called as a global filter. Any changes you apply on the data source filter, it is applicable for the entire Tableau workbook. Okay, so let's see one by one. Now, the dimension filter means in the SQL, if you have knowledge, in the SQL, there is a where clause. It works like a where clause. Measure filter will work like a having clause. Now, let's go to the Tableau. This is called filter box. You're seeing, right? There is a pages, there is a filter. This box is a filter. Whichever the filters you want to apply, you need to bring it here. Then only it will work. Now, I'm just simply creating this. Okay, before that, I'll just show you the views. This is called column. This is rows. Shelf, we call it as. This is the column shelf. This is a row shelf. This is the report creation view. So we call it as a pane, headers, and all. This is the marks card, wherein you can use it, color, size, text, detail, tooltip. After the filters, I'll show each and everything. And this is called filter shelf, pages shelf. Or you can go here and see in the format, the names. These are all called cards. Column shelf card, row shelf card, pages shelf, filter shelf, and the marks card. Now, if you go and hide it, I don't want column shelf, you hide it. Now columns is missing. You want it back, just go here, select on the columns. It will be there. Now let's bring the one report. I bring one dimension, that is subcategory, another measure. So you can keep it here or here, nothing wrong. When you put it here, it will be vertical, it is horizontal view. You can choose any like this and bring the measure. Sales is a measure, green color, blue is a dimension. So now sales I want to bring in. A simple report is created, horizontal bar. I want to convert into the vertical, just I'll select it into the vertical bar. So now this vertical bar is ready. Okay. So now this is a simple report. We created a bar graph. You have the list of 17 subcategory products are there here. See, appliances, accessories, art, binders, and so on. I want to filter it only 2 or 4.
Just a quick info, guys. Intellipaat provides Tableau online training and certification course mentored by industry experts. The course link of which is given in the description below. Now, let's continue with the session.
What you do is bring the subcategory, that is where is the subcategory, onto the filters, drag it, drag and drop. Here I dropped it. So now here you can choose various ways. I don't want accessories. You can deselect it. I don't want copiers. You're seeing here, right? The field is subcategory summary, selection 16 of 17 because I removed one. If I select this one, 17 of 17. So you can choose whichever the ones you don't want to display. I'm removing 4 subcategory products now and click apply. Now total 13 selected out of 17 values. So this is the 13 products report. Understood? So this is called dimension filter. You're bringing a dimension onto the filter box to see what all the data items you want to see the sales value. If you want to remove some of them, again, go and click on this drop down, edit filter. Appliances, art, chairs, furnishings, labels. Now I have only 8. Apply. Only 8 products are there. This option is called general, select from the list. Now I want all back, all apply. All the 17 are back. Now go to the wildcard. In the wildcard, instead of selecting the general, you can go to the wildcard. You can give the matching values. You can say that the name, the product names contains S. In the entire products, if S is there, it will identify. I think every product has a S except the art. So now art will be removed. See, contains S, apply. Yeah, art is removed, rest all the products are there. You can go and see here. The wildcard condition you gave contains S. Now, otherwise, if you want to give it as starts with, my selection should start with A. Means all the products with the name starts with the A, it will display. We have only 3 accessories, appliances, and the art. Or ends with. I want to end with A. No product is ending with the letter A. That is why it is not giving. By the way, this is not case sensitive, so you don't need to worry. If I give end with S, 14 products are ending with S. So it is displaying. Exactly matches. You need to give exact name, then only it will match. Art, apply. So now only art. So wildcard is for that. If you don't want this one, you can go ahead and clear it off. Now apply. Everything is back. Now you have a condition. On this particular dimension, you can use a measure as a condition. So go to the condition by field. Field is sales field. I want to select sales. Sum should be greater than 100K. Apply. Only the products which has a sales value greater than 100K it will display. I want to bring the sales onto the label. Click OK first so that you all can see. See, everything is greater than 100K. Or maybe I'll show this view. This is much better as of now. Everything is greater than 100K. Go to subcategory. Edit filter. Condition. Give less than 100K. Now, whichever the products has less than 100K sales, you can see all. You have another option in the filter that is called top. I'll remove this one now. I don't want. Click on none and apply. Everything is back now. Now go to the top. Here, top, you can give top and bottom numbers. I want to give top 3 by sales. So this means top 3. This is on the subcategory you're preparing it. Top 3 by sales, sum. Click apply, OK. The top 3 products you can see. Or go to subcategory edit filter. Select bottom 3, the least values. Apply. These are the bottom 3. Or you want top 5. Just give the number top 5. Apply top 5. So like that, you can choose either top condition. If you don't want none, apply. So everything will be back. You can choose a condition. You can choose a wildcard. You can choose a general. So this is called dimension filter. What I want is I want all of you to just practice it for a few minutes. Don't take subcategory. You can take any dimension. You can take customer name. You can take state, anything for that matter. Just go ahead and select. All of you select this table in the show me. Select this first table so that you can see the numbers and you can try. So this is called on the dimension. Okay, and one more thing. For example, I have 2 measures. One is sales and one is profit. I want to give condition for both. what you can do is go to again subcategory, edit filter. In the condition, I want to give by formula. Here, what you can do is I want to write sum of sales should be greater than 100K and sum of profit should be greater than 20K. Both the conditions should match. Apply. Now, when I match both the conditions, only 6 subcategory products are matching. Greater than 20K, greater than 100K. Okay. If I want to make it or condition, go to the condition instead of and, you can give or. Either one condition it has to match. Apply. See here, negative 3,473 it is giving. So this means profit condition is not matched, but whereas the sales condition is matched greater than 100K. So that is why bookcase is added. In the paper segment, sales is not matched, but profit condition is matched. So that is why even paper also displayed. So this is called and or function. You can use it as a calculation here by formula. The next one is the measure filter. So I'm removing this one. Again, I'll bring my subcategory, the sales. For the measure filter, you need to bring the measure onto the filter. So measures are sales, quantity, discount, and profit, right? So here sales is there. I want to bring the sales onto the filter. Now this dialog box will be different because measure is a continuous value. You will see the aggregations, either sum, average, median, count, distinct, minimum or maximum values. So right now I'm selecting sum. Here, the minimum value to the maximum value it is giving. So this is the one. 3024 is the minimum value for fasteners. That is the minimum overall all the subcategory products. And max is a 330K, which is a phone segment, right? So now I have both in between. If I want to reduce it, I'll reduce like this. So increase it. What is the minimum value, maximum value? Apply. Now between 51K to 254K, how many products are there? Or you can type it between 100K to 200K. So you can give the range of values. This is called range. You can choose the range of values and you can show the filter. Second one is you also have at least minimum value. You can change it always. Sometimes I want to change the minimum value to 5,000. Apply. Sometimes I want to change it to 50. Max value, you cannot change it when you select the at least. It will remain 330K. Minimum only you can change. Now I want to keep it 100K. So minimum is 100, max will not change. At most, I can change the highest value, but minimum value I cannot change. So I'll select 50,000 this one. Apply. So minimum is 3,000. That won't change. 50,000 is the highest or 100K is the highest. So this is the at least, at most range of that. Second one, last one is a special. You remember yesterday when I was showing the blending, I shown the how to do the non-null values, null values, right? So you can choose. If there are any null values, you can choose go ahead with the non-null so that you cannot see the null values. This is called your measure filter. The third one is the quick filter. So quick filter is nothing but when we created here subcategory sales, quick filter is click on the drop down, show filter. This is called quick filter. End user can play around now. They can interact. Suppose end user wants to remove tables. You can remove the tables, envelopes, copiers. See, this is called quick filters. The end user can choose. If you want all, just click on the all and everything is back. How to enable this one? Go to subcategory here or here, anywhere. Show filter option, select, reselect. And dependent filter, I created a filter on subcategory. Now I want to create a filter on profit also. Measure filter. I'm using the measure filter. Sum of profit. I want to give the least minimum value 0. I don't want negative values. Apply OK. So bring the profit and check whether it has given right or wrong. Yeah. So negative profitable values are removed. Now show this as a filter. Measure filter. If you increase this one, even negative values are also back. I'm changing the range. Either you can type it. If you give 0, now negative values are gone. If I take everything, negative 17K is also there. Negative 3,400 also there. Everything is displayed. So this is called dependent filter. Filter on filter you're creating. Okay, so let's move on to the next one that is called data source filter. Like I said, data source filter is at the data source level here, this page. Now in the data source, the top corner, right-hand side corner, you have a filter is available. When you do whatever the changes in this one, it is applied to the entire workbook because it's a data source changes you're doing. Now let me go to the sheet 1 here. Sheet 1 has, so here we have the regions, right? Okay, this is good enough. Now go to the data source, filter, click on the add. This box will open and again click add button here. So I'm creating a filter on the region now. Select region, click OK. I want to select only south and west, for example. I'm selecting only these two. Click OK. Now the overall 9,994 rows have become 4,823 because it is doing at the data source level. It is reduced. Data source itself is reduced now. Now go to the sheets. In the sheet 2, now you have only South and West. Go to the new sheet. Just bring the region. Here also only the South and West. Go to another sheet. Bring the region. Here also only South and West. So when you do the changes in this data source, it will be applicable to the entire work. Got it? Now the next one. So this is called your data source filter. Data source filters are really helpful because what happens is when you connect to the servers, data servers, suppose your organization have 10 years data, 15 years data. We don't need all the data, right? We just need only a couple of years comparison, maybe 2 years data, 1 year data only I want to do. Just go and filter it there itself so that your data load will reduce. That is called data source filter. Okay, so this is about the data source. And the last one is called context filters. Now, context filter also work like a data source filter, but at the sheet level, you can do it. So I'm removing all the filters as of now. Remove, just go and select remove it. All my data is back and the sheet also I'll clear it because I want to create something different now. You can click on this button. It will clear the sheet. Clear the sheet. What we can do is now go to the sheet 1. I'm preparing a simple report that is a subcategory sales. Another report. Okay, here subcategory and the region. Now another report I'm bringing here, region and then the order date, the sales. Third one, region wise, here state and then the sales value. So if you observe, for every sheet I'm giving the region as my common dimension. I'll go to the another one here, bring the region sheet mode. Now 1, 2, 3, 4. Okay, 4 sheets are there. Context filter, how does it work? First thing, I want to create a filter on the region. Go here, take the region, put it on the filter. Apply. Okay. Now here, I want to choose edit filter. I want to choose only central and east. Southwest, I don't want. So a report is created. This report shows central and east data. Now go to the sheet 2. Here, this remains same. Sheet 3, all the regions are there. Sheet 5, all the regions are. Now, if I want to apply the same filter for all these sheets, what you can do is go to the region, filter, first sheet wherever you applied, apply to worksheets option available. When I select apply to worksheets, you can choose selected worksheets, only this worksheet, all using this data source, all using related data sources. I want to apply selected worksheets. Now I have total 5 sheets, 4 sheets are there. So I want to apply the same filter for sheet 3 also, but I don't want for 2 and 5 and click OK. Now you go to the sheet 3, you can see central and east. Whereas in the sheet 2, all the regions are there. Sheet 5, all the regions are. So what you have done, you have applied to the 2 sheets, that is sheet 1 and sheet 3. So this is called multiple sheets. You can apply same filter without creating again the same filter in that sheet. You can go to the sheet and go ahead and select apply to worksheets. Now the second option, the context filter now. How do I do the context filter? What does the context filter will do? When I create a filter on top of it, if I'm bringing another filter subcategory, what happens here? There are 2 filters, right? So the flow is not defined here. Sometimes I can take everything. Sometimes I can remove it from here. So it is like I can choose here, I can choose here. Now context filter, what I'll do is I select only the central and east. Now on top of it, if I'm applying the subcategory filter, it will go only for these 2 data only. So if I remove the machines, it will be only for central and east. South and west is not applicable. So this is what I'm fixing it so that my dependency is much better. So for that, what you do is you remove the show filter option, go here, region, make it as add to context. Now it will become gray color. Now on top of it, whatever you are creating the filters, now sales filter also I want to create. It will be only for region central and east only. Some I'll give. I want to give minimum value is 50K. For central region, copies and machines does not have. For east region, it has. So this is now context. So whatever I do on top of it, any filter, it is only for the region central and east only. That is called context. So now the same context filter I want to apply for the other sheets also. What you do, go to the region, click on this, apply to worksheet, the context, selected worksheets. Now I want to apply for sheet 5 and sheet 2 also, except sheet 3. Click OK. Now go here, automatically central and east. Now this is gray color. Go to sheet 3. It is not applied because I have not given the option. Go to sheet 5. Now on top of it, if you are bringing any other filters like ship mode, I want to bring the filter. It is applicable to only central and east. Second class, I'll remove, apply. Now you have only central and east. So this is called context filter. It works like a data source filter, but it is at the sheet levels. The last one is called extract filter, which is normally also it is not for the user, only for us for the data source. That is nothing but when you click from the live connection to the extract. So here extract, edit option is there. Once you select the extract, this is available only for the desktop, Tableau desktop. Click on the edit. Here you can give the filters, add the filter, the date or whatever you want to add it, you can give the add filter. This is called extract. Most of the time we don't use this one. We use only from the data source onwards. You can choose even the extract filter also. Okay, so that's about your filters. The next one is we will understand today what is about marks card, shelves and all. So let's start with what is marks card. The marks card, we have options like, so you have an option called automatic and all. Here the charts option available.
Just a quick info, guys. Test your knowledge of Tableau by answering this question. Which of the following is not a trend line model? A. Linear trend line. B. Exponential trend line. C. Binomial trend line. D. Logarithmic trend line. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
There is a color, there is a size, text, detail, and the tooltip. Okay. So when you bring a specific dimension or a measure, what happens is it's a text table. So you're seeing it automatic label values are on the label. So that is why it is showing T. That is a text on the label. Go to the show me. You have the predefined charts here. So select the text table, though it is a by default, but I'm selecting a text table now. Now, if I select a chart, so what happens? Your text values will move to the column. Then it is showing a chart, right? Now this is the rows is on the dimension, measure is on the column. I want to swap it. So go and swap rows and columns. Now measures are on the rows and dimension is on the column. Okay. So here in the marks card, now by default, the moment you change your rows and columns, dimensions, measures, it is showing automatic is bar graph. Fine. Next thing is the color. By default, it will give you the blue color. I want to change the color. Click on the color. You can change various colors here like this, or you can bring the dimension onto the color or a measure onto the color. Here dimension is subcategory, measure is sum of sales. Suppose if I bring subcategory onto the color, each subcategory is given a different color altogether. Or if I bring the measure onto the color, what measure is doing? Single color in the gradients it is giving. Now let's understand what is this all about. When it is a single color gradient, because it is a continuous value, that is why one color with the sales value changes, it is giving the gradient change. This color combination, you can go up to 3 colors in the measures. That is, click on the color, edit colors. You can choose red, green, gold, diverging. This is called your rack tracker color. Maximum 2 colors or 1 color or 3 colors you can choose. Temperature diverging if I give, there are 3 colors temperature. And in each 3 color, the variants are there. Stepped color, if you want only to give only 3 colors, 1, 2, 3. But in the 3 variants, if you want to give, you just need to increase it. So this is a variant in those 3 colors. Because it is a continuous value, it cannot take more than 3 colors. Remember that. Now, but if I bring the dimension, each dimension is a discrete data item. That is the reason every dimension, one color is assigned. It's not a continuous value. It is a discrete item. So when I want to change the colors, click on the color, edit colors. Accessories blue, I don't want. I want to give some other color. So go to the palette. I want to give red. In this red, I want to give this dark red. Apply. Now my accessories color is changed. Go to appliances. Appliances light blue. I don't want. I want to give gray color. Gray. Select this gray, dark gray. Apply. Now this is gray. So like that, you can change for every data item one color. I don't like supplies, very light color is there. I just want to give purple, something like darker purple. Now tables is also purple color. I want to change from that to lightning dark, where I want to give this color. This is so you can go ahead and change for each and every data item in this dimension, one different color. So that is the color option. If you're choosing the measure, then maximum 3 colors with the gradients you can give. But for as the dimension, you can give each data item. For example, if I bring customer name, every customer you will see individual color. So now bring the customer name onto the color. See, every customer one color is defined. If I choose the measure sales onto the color, so one color with the gradient, because it is a continuous value. That is why blue color with the variance basis the sales value. This is called color combination. Okay, so this is on the colors, and next thing is on the size. So what is the size? Size means depends on the measure. If you are using by default, what happens is the width of the bar graph is the same. The height will change as per the sales value because you're choosing the measure there. Suppose if I want to change that also, bring the sales onto the size so that your bar width also will change like this. Normally this size we use it for the pie graphs, that is region sales. And then I go ahead with the, so this is basically the sales values on the size so that the portion size will change. But if I don't have the portion size, sales on the size, everything will be equal only. Even the angle also if I remove, everything is equal. But this is pie graph, you can use the sizes. But if you want to use for the bar graph, you can use. But this is where it will look. The size, you can do the changes. Now, the label changes, what all the options we have. Go to labels. Right now, the 9 point, you can change it to the 8. You can change, increase it, whatever you want, you can do like this. And then you can make it bold. All options available. For example, if it is font is done, alignment, center I want to give, or vertical automatic, the automatic option to the center, top, bottom. You can choose any of these options and directions, and then wrap on. Like if we have more than 17 subcategories, it is fixing here. Suppose each customer I have to show in a single view, then you can choose a wrap on, off. You can choose. This is on the alignment. And marks to label, this is interesting. This is all when you select every subcategory, the values are showing. If you select selected, what happens is if I select any specific bar, then only the value will show. Suppose I'm selecting chairs, that is why chairs is showing. If I select phones, it will show phones. If I select binders, it will show only binders. So that is called selection. You can also have another option called minimum and maximum values. It will display only min and max. See, minimum is 3024, max is 330K. Only those two values, wherever they are, it will show. And the last one is called highlighted because your data is a highlighted option, right? So when you bring in subcategory onto the color, if you select one envelopes, then the value will show. If I select paper, then it will show paper only. Accessories. So this is called when you highlight something, then only the data values it will display. Okay, so this is on the labels. Sometimes what happens is when you have so much data, you can choose this option, allow labels to overlap other marks. Because, for example, in the label size, the font I'm giving more as 12 and label all. So when I give like this, it overlaps. At that time, what you can choose is label, allow labels to overlap so that all the labels will display. This option is for that. Next one is a detail. Detail is something, if you want to detail it. For example, each subcategory, I want to detail it with the region. Drag the region onto the detail. Now you can see the details now. This is what you have asked. See, it will give the accessories a breakup because you're choosing a detail on the region. See, now it is overlapping. Everything is showing. If you don't want to overlap it, deselect. Whatever maximum it can show, it will show. Now the total is totally different. If you want to show even the total also, that we will do it later. But when you choose any other dimension on the detail, it will detail. This is the west region, this is the south, this is the east, and this is the central. For every subcategory, it is giving all the 4 regions breakup. But this is not a right way of the representation. We'll do it later, what kind of charts we can see. But detail will give you the detail information. Remove the region. You can keep the detail and you can remove the label also. Now I can see only the breakup. And the region, you can bring it onto the color instead of subcategory. See, every subcategory is further divided into 4 regions. Central, if you select central, you can see all centers. If I select east, this is called highlighting. It is selecting east. South, west. This is called legend highlights. So this detail part, region-wise detailing it. Okay, so the next one is a tooltip. Tooltip is by default, when you hover around, you're seeing the tooltip information, right? So this is called tooltip. So what are the fields we used? We use the region, we use the subcategory, we use the sales in this chart. So that is what this is called tooltip. If I want to do the changes on the tooltip, click on the tooltip. I don't want to display the region or subcategory because subcategory name is there. We don't need. Just go and remove the subcategory. Click OK. Now, when you hover around, now the subcategory is removed. Only the region and the sales value. If you want it back, just go to the tooltip, go here, insert. Whatever the fields you use it, it will display here. Click on the insert button, click subcategory. Now, this is a dynamic value greater than and less than symbols. You hard code it because you need to give the header name also. Subcategory. Click OK. Now your subcategory is again back. This is called tooltip. Tooltip is really useful when we are learning the calculations, LOD expressions and all. Very interesting, this one. So that's about the marks card. And marks card, another one is there that is called your various types of charts. I can show line, I can show area, square boxes, circles, shapes. When you click on the shapes, you have another button called shapes is enabled. You have a lot of shapes available here. More shapes, default, filled, arrows, bars, bug tracking, gender, KPI, proportions, ratings, thin arrows, and weather. Suppose if I'm selecting weather shapes, like this. We will learn in detail this one later, but you have options in the shapes, it is available. You're choosing maps. If map is possible, it will show map, otherwise no. Pie graphs, because proportions are not there, that is why it is showing circles. Gantt bars, polygon, and then the density. Okay, so these are all the charts options. This we will learn anyways later. But as of now, you understood in the marks card, you can do colors, you can do size, you can do label, detail, and the tooltip. That is about the marks card. So with this, what we have done is we have learned filters. We understood what is marks cards. Now we'll move to the folders. How to create the folders and how to create the groups and the sorting. Okay, and then we'll close today. And next week onwards, it is going to be 3-hour session for all of you. 8 p.m. IST it will start and it will go up to 11 p.m. IST. Okay, to clear the sheet, just go and click on this one, clear the sheet. The sheet is cleared. So now let's do the sorting first. In sorting, there are 3 types of sorting available. One is the alphabetical sort, another one is a data source sort, and then the field sort. Okay, so by default, it is a data source sort. Suppose if I bring subcategory and sales, what is happening by default data source? Data source is alphabetical A to Z, ascending. If I want to change this into the other sorting, click on the drop down of that particular dimension. Sorting will happen only on the dimension. On dimension, you can choose the measures. Okay, go to subcategory, click on the sort. First one is a data source order. You are in this. Alphabetic, it is also same. A to Z, ascending or descending. Third option is a field. Now I want field sorting by sales because I brought in the sales. By sales, either ascending or descending. Ascending or descending. You have another option called manual. Manual, I want to push furnishings is in this place right now. 3, 4, 5, 6, 7th place. I want to take it up to the first place. Furnishings, I took it up to the first place. So this is called furnishings into the top place. So this is a manual sorting. Appliances, I want to put in the second place or first place. Now appliances first place. This is manual. There is another option called nested sorting. Nested sorting, what it does is I have 2 measures now, sales and profit. Okay, so subcategory is only one you can do the sort, 2 you cannot do. So nested sorting will help. Suppose, for example, I sort by sales, highest to the lowest. Now, if I want profit, then I'm changing. This is called nested sort. Now it is profit sort. Or if I want to sort by sales, like that, you can choose in between 2 measures, which measure you want to sort. And always remember, it will be only on the dimension. On the dimension, you can choose the sorting of your measure. This is called sorting. Now you can go ahead and put the chart. These are the shortcuts. Descending to ascending, ascending to descending. Select it. Now highest to the lowest or lowest to the highest. Now we completed the sort. The next one is we can create the folders in our data. Yes. So how to create it is what I'll tell you. By default, when you load the data, it is called group by data source table. First step is change this into the group by folder. Here, go here, click on the drop down, group by folder. Now you'll see the folders option. And one more important thing is there is no compulsion to create the folders. It is to ease our work. Okay, it's not a compulsory thing. Now, folder is created here. Now go to the product folder. Let's create product folder. All the product related things I want to keep it in the product folder. So go to any one product option here. Create is there. Not this one, sorry. Folders is there here. When you click on any particular dimension, click on the drop down, folders, create a folder. Now give the folder name. I want to create the product folder. See, there is a folder created. A product ID is there. I want to bring the product name also into this. Either drag and drop like this or category also I want to put in the folder. So just click on the drop down, go to folders, add to folder you can choose. Now category is also part of product. Subcategory also I want to take it to the folder, drag and drop. Now there is a product folder. The same way you can create customer folder. Go to customer ID, folders, create folder that is called customer. Customer ID, go to customer name, folders, add to folder that is customer. Now customer name. Segment also I want to put in the customer folder, drag and drop. So now customer folder is ready. I want to create a location folder. all the geo related things, I want to keep it in the folder. Just go ahead and do. So like that, you can create multiple folders. I'll go to the region, countries, city, and then the location related things. Now the same thing order, you can choose shipping, you can choose. So like that, you can create the folders. Yeah.
Just a quick info, guys. Intellipaat provides Tableau online training and certification course mentored by industry experts. The course link of which is given in the description below. Now, let's continue with the session.
We'll be starting with calculations and expressions. We will look into what are LOD expressions, and we'll also discuss about groups. We'll go into our workbook, okay? And we just went through how to create a calculated field and how you can just go through the list of inbuilt calculations and functions that are available in Tableau with the corresponding syntax, with an explanation of what it does, and with an appropriate example. Right? So today we'll see what are the different table calculations, and we have something called quick table calculations. How can a quick table calculation be quickly applied to our table, right? So for that, let me just create a text table first, right? Now let's have our order date in terms of years in our column, okay? Next, we'll have our order date, okay, in our rows as well. But this time I'll just click on this drop down arrow and I'll choose the discrete quarters of order date. And then when I drill down, now this is the table that we have tried to visualize. We have the different years that we have in the order date dimension. And we also have the different quarters and the corresponding months under each quarter, right? Now let me just expand this a little bit, and you can also format it. We shall increase the font, right? And then we shall place the value of sales in the text part, right? So now this is a simple table that we have visualized. Now let's try applying the table calculations one by one on this table, and let's see what are the different ways of computing, what are the various options available in the edit table calculation dialog box, right? So when you click on this drop down arrow right next to your measure, right in the pill of your measure, okay, you have this option called quick table calculation. Now you can apply quick table calculations only on measures, okay. Just click on this drop down arrow and you have this option called quick table calculation, and this is the list of the quick table calculations. They are nothing but table calculations which can be quickly applied to your table, right? So that is why we call it as a quick table calculation. Now let me say I would like to find the running total of sales, okay, and this is how the running total of sales is calculated, right? So when you look into the values, we have January 2015, and when it comes to February, we have the value of January that is summed up with February, and the sum of both is placed, I'm sorry, not of February. This is done in a horizontal manner, right? Which means it moves from January 2015 to January 2016 to January 2017, and finally the sum of all the 4 Januaries is placed in this last column, first row of last column, which is nothing but January 2018, right? And similarly for February, we have 4,000, which is summed up with the value of February 2016, and the sum of both the Februaries, which belongs to 2015 and 16, is placed over here. And then it moves ahead, and the final value, which is the sum of February 2015, 16, 17 plus 18, is placed in the second row of the last column, right? So this is one way. This is the horizontal way in which your running total is calculated. Now you can change the way your calculation is getting computed, right? Or the direction in which your calculation is getting computed, right? Now, when you click on this drop down arrow, you have an option, you have a separate option which appears now, and this is known as the compute using, right? Now, basically, table calculations are defined by how they are partitioned or grouped and how they are addressed. Addressed is nothing but how they are computed or in which direction they are computed, right? Now, when you click, now by default, it is computed in a horizontal manner, okay, table across the table, the calculation is computed, and this is the by default way of your calculation by which it gets computed. Okay, when I click on table down way of computing, okay, now there's a vertical manner from top to bottom in which the calculation gets computed, or the running total is calculated, right? So for the year of 2015, we have January value, we have February value summed up with January value that is placed over here. Then we have the first 3 months sales value, which is placed in this March, and so on. This goes on till December 2015, right? So every column, you can just verify this, click on analysis, you can go into totals and say show column grand totals, right? So that you'll be able to clearly verify that table down, computing any calculation, or for example, running total calculation in a table down manner is equal to the grand column total that we have calculated and displayed in our worksheet, right? So this is table down way of computing. Let's try the table across. Okay. Now, when it comes to the table across way of computing, when you try to display the row grand total, you'll be able to see how the row grand total matches up with the last column values over here, because the running total is calculated in a horizontal manner across every row, right? So that is why we just verified it with the column grand total and the row grand total, right? You can just remove them. And I also have, now let me just tell you about the next way of computing. Now it was table across, which moves in a horizontal manner from left to right across the table, right? Then we have the table down way of computing. It moves from top to bottom in a vertical manner, okay? And then we have table across, then down. Now this is table across. First it moves in a horizontal manner, then it moves to the first column of the next row, and again it moves in a horizontal manner, right? So I have a simple diagram for this with which you'll be able to understand. Yes, table across is nothing but it is just in a horizontal manner from left to right. Okay, table down is in a vertical manner from top to bottom. Then we have table across, then down, which means it moves in a table across manner, then moves on to the first column of the next row, and then moves again in a horizontal manner across the table, and then goes down to the next row of the first column, right? And this goes on, and the final value is placed in this last row of the last column, which means in our example, the final value is placed in December 2018. So the summation of all the values that we have in our data set for all the different months and all the different years, this is the final sales value that is placed right here in the last row of the last column, right? This is computing using table across, then down. And similarly, we have table down, then across, right? Now this might look meaningful because it moves in a vertical manner from top to bottom, and it carries on this summed value of the first year to the starting of the next year, and this goes on, and the final summation of the entire values in this table is placed in the last row of the last column, which is nothing but December 2018. And when you look into this diagram, this is how table down then across way of computing is carried out. It moves in a vertical manner from top to bottom first, which is table down. Then it moves across to the first row of the next column, right? And then again it moves in a downward direction, and this goes on till it finally reaches the last row of the last column, which will contain the sum of the entire values of whatever is present in this table, right? Where we will use this. Yeah, when you need to calculate the sales or profit that your organization has done, might be you would like to compare what is the total sales done in every year. When it comes to when you have 4 different years, you can just try calculating. You can either show the column grand total. Yes, definitely. both results are the same in the sense table across, then down, table down, then across, right? I think you're talking about these two. Okay, now when it comes to table across, then down, the way the final value might be the same, right? But the way you're calculating differs, right? Now in this way of computing, which is table across, then down, so you can simply, compare of how it moves in a horizontal manner, right? So month by month, you can keep calculating, and you can also apply a secondary calculation on this, right? So we'll look into that. And when you look into table down then across, you can clearly understand what is the total value of sales at the end of the first year and what has happened at the end of the second year. So far, for these 2 years, what is the total value of sales, and so on. You can just, totally depends on your requirement. Though both the final values of both these way of computing the calculation is the same, the method and the way it gets calculated is completely different, right? So yes, it all depends upon your requirement. If you have any such requirement in your real-time scenario, then you just have this option that you can go ahead, right? So this was about the first 4 ways of computing, right? And just like these, we have pane down, pane across, then down, pane down, then across. Now, what is a pane? Pane is nothing but the sub-partition that we have. Okay, this is the quarter 1, this is quarter 2, quarter 3, and quarter 4. Now, we have computed it using pane down, which means the value of the first 3 months of quarter 1, the summation of quarter 1 of 2015 is placed over here. The summation of all the sales value of 2016 of quarter 1 is placed over here, right? So this is something like a subtotal that we have when you compute it using the pane down option. And then we have pane across, then down. Now across, then down, this is again, it moves first in a horizontal manner, moves to the first column of the next row, and this way of computing is done till the end of the first pane, right? So till the end of quarter 1, which is March of 2018, we have this running total which is carried on, and after which it freshly starts from the April month of next quarter of 2015, right? So this is, you're computing it for every pane, for every quarter. You are simply computing it either pane down then across or pane across then down, right? And this was the way of computing, and you can just look into these diagrams. I'll be sharing this file as well. Okay, now let's try applying the next, and you can clear your table calculation with just one click. Okay, you have an option called clear table calculation. Only when you have already applied any quick table calculation, you will have the option to clear the table calculation, right? And next comes difference. This is how the difference between two values get calculated. Now, why is the first column completely left blank, right? Now, whenever you would like to calculate a difference, you need two numbers, right? Only then you will be able to calculate a difference between these two numbers. So when it comes to difference, we have an extra option over here called relative to, right? And by default, relative to is previous, and by default, compute using is table across, right?
Just a quick info, guys. Test your knowledge of Tableau by answering this question. Which of the following is not a trend line model? A. Linear trend line. B. Exponential trend line. C. Binomial trend line. D. Logarithmic trend line. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Calculate the difference from, and that is why it is left blank. And then when you look into the next year of 2016, a difference has been calculated between 2016 and 15, and the result is placed in this column, in the second column under 2016, right? So this is how your difference is getting calculated relative to the previous value. Whatever previous value is present in front of it, according to that, your difference is getting calculated. Now, what if we say relative to next value, right? Now, 2015 has a next value. So yes, a difference is calculated and placed in the first column, and this goes on. But when you look into the year 2018, you do not have the next year from which the difference can be calculated, right? So that is why 2018 is completely left blank, okay? And next comes the first and last, right? Now when I click on first, so we do not have a blank first column. We have the first column which is completely filled with 0, right? This is because we are calculating the difference from the first value, right? So which means first value, the difference between the first value and the first value is 0. The difference between the second value and the first value is so and so, right? So every column is compared, is using the first column in order to calculate the difference, right? And similarly, when I say relative to the last column, we will have the last column which is left, displayed as 0, because last column subtracted with the last column is again 0, right? So these are a few ways by which you can calculate the difference between any two numbers, okay? And you can change how, in what manner or between which numbers you are calculating the difference from, right? And with one click over here called clear table calculation, you can simply clear whatever calculation you had applied onto your table, right? And then comes the percent difference. Now this is very similar to difference. Now the only change is that your difference will be represented in a percentage format, right? So that's the small change when it comes to percentage difference, and you again have relative to options that you can choose from, right? Next we have percent of total, right? Now when I say percent of total and it is computed using table across, which is the default manner of computing your calculations, right? So when I say percent of total, so out of a total of 100%, okay, what is the contribution of this particular year which belongs to, or this particular month which belongs to 2015, 16, 17 or 18, right? Now let's try, I'll just change the way it is getting computed, right? Now when I try to show the column grand total, you'll be able to see we have, when you sum up all these values, you will arrive at a total of 100%, which means out of my total, which is 100%, what is the contribution of each month in every year, right? So by doing this, I'll be clearly able to see that in the year 2015, it is September month which has done the highest or contributed highest towards the total value of sales. And similarly, when it comes to 2016, we have the month of November, which has contributed the highest value or the highest amount of sales when you look into the total sales, right? So this is just the percentage, the contribution of this particular month out of 100%, right? So which means when you simply sum up all these values, you will arrive at a total of 100%, right? So this is how you make use of the percent of total calculation, right? Then we have rank, okay, just with a few rows and a few columns, and we have 5 different functions under rank. We have rank modified, rank unique, rank dense, rank percentile, and the simple rank. So we'll just go through rank right after we complete the remaining options that we have, that you can apply, that you can make use of in while using your table calculations, right? Then we have percentile, right? Now when you say percentile, now it is computed using a table across option, right? So it is in a horizontal manner. The least is given 0%, the highest is given 100%, and in between values are given equal percentages according to their contribution to the total value of sales, right? Now let me just change the way it is getting computed. Let's go ahead with table down. Now when you look into this, when you sum up the entire rows of my first column, you will not arrive at a total of 100%, because this is the percentile calculation, which means the highest of all is given 100%, the least of all is given 0%, and all the others out of 100%, whatever is the contribution of each month is clearly specified in this as a result of this calculation, right? So every single month is calculated as of what is its contribution out of the total, out of 100 percentage, right? So this is not something like the percent of total. There's a small change between percent of total and percentile calculation that you can make use in Tableau, right? Now, next we have our moving average. Now, when it comes to moving average, we have two different types of moving average. We have the simple moving average and we have exponential moving average. And simple moving average, I'll create a separate table for that, and I'll explain what is moving average all about. And when it comes to exponential moving average, that is the inbuilt forecasting tool that we have. Yes, I think you're asking about the forecasting. Can we predict Q4 based on 3/4 percentile? 3/4 percentile. Now, prediction, it comes under, I think you're talking about forecasting. Yes, definitely we can forecast values, but you should have enough historical data, okay, in order to forecast values. So yes, we'll be looking into detail about forecasting as well. So yes, definitely. And as of your question for now, yes, you can definitely predict your quarter wise, your month wise, or your day wise values of, you can predict day wise in any terms, year wise. It totally depends on what amount of data you have with which prediction can be done, right? So we have a few basic criteria for that. Yes, we look into that in detail when we move into that topic of forecast analysis. Okay, so now as of now, this is, yeah, and then comes the moving average. Okay, now we have a few calculations involved under moving average. We'll go through that in detail as well right now. Okay, then we have year to date total, right? Which means if you have till date, a data set which contains till date information, you can simply make use of this year to date total, and you can calculate the compound growth rate or year over growth. I mean, year over year growth, how your growth has been throughout these years, or again, your year to date growth will be calculated when you have a data which contains information or data till this particular date, right? Till date, the current date, right? So these are some of the calculations that you can quickly apply to your table. That is why they are placed under quick table calculations. And we also have, when you apply any quick table calculation, you have an option called edit table calculation over here with the delta symbol, right? Now let me just clear the table calculation, and I'll also remove the column grand total, right? So now when you click, let's say I'm going to make use of the running total. Now, as you notice, right next to your measure, you have a delta symbol or a triangle symbol, which indicates that this is a measure on which you have applied some kind of table calculation, right? So that is why your sum of sales is has a small delta symbol right next to it, indicating that you have already applied some calculation on this measure, right? And after applying a calculation, you'll be able to view this edit table calculation. Now, this is the dialog box which appears. We have, you can simply decide what calculation you are going to make use of. Okay, what is the aggregation you are going to choose in order to calculate the calculation, and the ways of computing. You can choose the way of computing using these options itself. Okay, and when it comes to specific dimensions, now this is something like, I hope you remember we had something called selected, or we had targeted highlighting, right? You can select fields with only with which you would like the highlighting to be visualized in your data, right? This is something like that. We have specific dimensions. As of now, year of order date has been the checkbox of year of order date has been clicked, which means it is the addressing field. Okay, addressing field is nothing but the direction in which it moves, right? So this is moving across the years. So we have year of order date as the addressing field, and we have month and or quarter as the partitioning field, right? So it just partitions the calculation using month and quarter, okay? Or you can also have your month and quarter as the addressing field, which means it will move in a downward direction, okay? When these are chosen as the addressing field, and you'll have the unchecked box which acts as your partitioning field. So your calculation goes in this way, and there's a partition. You can just imagine there's an imaginary partition between every year, every column, and that is why year of order date is considered to be the partitioning field when you choose the options in this way. So the boxes which are checked, they act as addressing fields, just the direction in which they move, in which the calculation moves, and the unchecked box act as your partitioning field, right? And we have this option called restarting every. You can restart every month, okay? Or when you have, let's say this, you will not have your restarting option because we have only the month and quarter as our partitioning fields, right? So there's no point. You do not have an option to restart every month or every quarter, right? So this is one option that you have. You can just decide upon them. These are different ways by which you can calculate your let's say your values of sales or profit or any such values, right? These are the different options that you can make use of, and that again purely depends upon your requirement, right? So this was about partitioning and addressing fields, and we also have, you can sort them out. Okay, let me just create another sheet. Now let's have the different subcategories. Let's have the different categories, and then let's have the corresponding sales, right? Now let me apply a quick table calculation, let's say of running total on this table, okay? And it is computed using table down, okay? And now let's try going into the edit table calculation dialog box. Okay, now when you click on specific dimensions, you can simply decide whether you would like to, in this we do not have any partitioning field, right? Because we do not have anything in our column shelf, right? So this is, as I told you, it depends on what and how you have visualized, you have created your table, right? And then I just wanted to tell you about this. When I say sort order, in terms of specific dimensions, you can just customize it. You can have it arrange your sum of sales, okay, in either the descending order or an ascending order, right? So it just starts from the least value of sales, and then it goes on to the highest value, where we have phones is the subcategory which has the highest value of sales, right? So the running total is calculated in an ascending manner, okay, which means from the lowest value of sales to the highest value of sales. And when you say descending, it will start from the value of sales of phones and it ends at here, right? So I think it is fasteners where it ends, okay? And when you click on ascending, I think it starts from fasteners, right? So yes, I think I said art. No, it is the fasteners subcategory which has the least value of sales. So it starts from this, else you can just sort it out in your descending order, right? So this is again up to you, whichever order you would like to go ahead with, right? And then we have adding a secondary calculation, right? Now we'll go back to our sheet number 1. Now let's apply. So we have applied a running total calculation and it is computing using table across, right? Now when I go into the edit table calculation dialog box, you have an option called add secondary calculation, which means on top of the result of my calculation that I've already applied to the table, on top of this I will add another calculation, right? Now if I say add a secondary calculation, we'll again get another dialog box which says secondary calculation type. Now these are the only options, these are the only type of calculations that you can apply as a secondary calculation when your primary calculation is running total, right? So out of the running total values that I've calculated, calculate the difference from okay, and it is relative to the previous value, right? So this is what you are applying, one calculation on top of the other, and where your first calculation becomes your primary calculation and your second calculation becomes your secondary calculation, the one that you're applying on top of the result of your first calculation, right?
Just a quick info, guys. Intellipaat provides Tableau online training and certification course mentored by industry experts. The course link of which is given in the description below. Now, let's continue with the session.
Okay, and now let's just go into moving average and I'll let you know. For that, I'm just going to filter out the date dimension, okay, so that I can explain the moving average with the most simplest set of data that we have, right? Now I'm just going to, let's say I'll bring my order date and I'm going to filter out, so that instead of getting the data of the 4 different years, I would like only 2015 years data. And again, I'll bring my year of order date, and this time it is going to be in terms of months, because I'm interested only about the month of January, right? Now, by doing this, when you bring in order date into your view, you will have only 2000 year data, only Q1 data, out of which only the month of January related data will be displayed. And these are the different days that we have in the month of January. Now you might see the days of the month of January starts from 3rd of January. We do not have 1st or 2nd, and we have 3rd, 4th, 5th, 6th, 7th, and we do not have 8th, right? And we have quite a few numbers or dates that are missing. Now this is because this is what you have been provided in your data set, right? So as a Tableau developer, you are just working with whatever data has been provided to you, right? So we basically are not concerned about the missing dates or missing data, okay? There might be it might be a holiday for the superstore, or it might have been there's no order that has been made on that particular date, right? So there might be n number of reasons for that, but basically we do not have entries for these dates in our data set, and that is why we are just continuing with whatever data we have that we have been provided with, right? So that is why it starts somewhere from 3rd January, because we do not have entries, we do not have data for 1st or 2nd January, or any missing date that we have in our data set. Okay, so now I'll bring the value of sales and I'll place it in the text part, right? Now this is the month of January of the year 2015 and the corresponding days value of sales, right? Now let's try applying the moving average calculation. Okay, now this is the simple moving average that we are going to discuss about. An exponential moving average, as I told you, we'll discuss in detail when we are forecasting with the data that we have, right? Exponential moving average is the calculation behind forecasting in Tableau. Okay, now let's try applying the simple moving average calculation on our measure called sum of sales, right? And for that, I am just going to create a duplicate of my sales, okay? And I'm going to bring this into my visualization, right? So now I have sales, copy and sales. So on my sales copy measure, I'm going to apply the quick table calculation of moving average. This is just to show you what is my actual value of sales, right? And from which the moving average has been calculated, what are the values of moving average, right? Just to compare between the actual value of sales and the moving average of sales, right? Now we'll go into the edit table calculation dialog box and we have a few options. Okay, now this is the window value, right? Now this window value is nothing but with respect to how many values you are calculating the moving average for this particular measure, right? Moving average is nothing but it is just a smoothing technique, or it just smooths out fluctuations in your calculations, right? So we have mentioned, so we have something called current value, null if there are not enough values, and when you have different combinations, the value changes accordingly. And in some cases you have a blank value on the first row, in some cases you have two blank values. Now let's see what happens with different combinations in these check boxes and what are they used for, right? So now basically a moving average is calculated by default with a window value of 2, right? Which means, now let me uncheck this box as well, right? It says, with respect to two previous values, I am calculating the moving average, right? Now, how does this happen? Okay, now we will look into the actual value of sales. Okay, now I have used 2 as my window value, which means with respect to two previous values, I will calculate my moving average, right? So when it comes to 16, okay, I do not have any previous value to calculate the moving average from. So that is why I have left the column as the cell as blank over here. When I move on to my second row, though I do not have enough two previous values, I should have two previous values to calculate the moving average from, right? I do not have enough previous values. I have only one previous value, but yes, that doesn't matter. I'll simply place that one previous value over here, right? But when it moves on to the third row, we have enough two previous values to calculate the moving average from. So it just adds up. It just says 288 plus 16 divided by 2, which is nothing but we have our value of 152 in our third row, right? So and this just goes on with the previous two values that you have. You calculate a moving average and you place that value right next to that particular row, right? Now this is what happens when you haven't included your current value and you are not displaying any null if there are not enough values. Now when I click on this null, if there are not enough values, what will happen, right? As I told you, when I am in my second row, I do not have enough previous values, but still, as I have just one value, I'm just simply placing that in this row. But when I say null if there are not enough values, my second row and my first row both become null, because for my first row, I do not have enough previous values, as well as for my second row, I do not have enough previous values to calculate the moving average from. That is why it is left blank. And only from the row where I have enough previous values to calculate the moving average from, I have my moving average of sales column, which starts, right? So this was about how do you null if there are not enough values. Now let's see what happens when I am going to include my current value. Okay, now as I told you, 16 did not have enough previous values, but since we have mentioned, or as we have mentioned, yes, you can include your current value also. It is simply displaying its current value. When you look into the second row, we have one previous value, and we are also allowed to include the current value, which means 288 plus 16 is nothing but 152 that is placed over here. Now, when you move on to the second row, it calculates the moving average with the two previous values, including its current value, which means 16 plus 288 plus 20 divided by 3 will give you 108. And this just goes on. Okay, now this is a small change that happens when you would like to include your current value or exclude your current value while calculating the moving average, right? So this was one option. And now let's see what happens if I'm going to display null if there are not enough values. Again, the first two values are displayed as null because they do not have enough previous values to calculate the moving average from, right? So these two options that we have, including and excluding the current value, whether to display null if there are not enough values or simply leave it as it is, Now these, we have changes that happens to the result when you have different combinations of these two different check boxes that we have, right? Now this was the concept behind simple moving average, or how a simple moving average will be calculated. Okay, now after this, I think we'll start with rank. I'll just connect Tableau with that simple file that I have, which is just for explaining rank. I have this rank sample. As I told you, it's a very small data set. We just have very few number of rows and columns. Okay. Yes, this is rank sample. I just have 2 columns and I think around 5 rows. Okay, in this rank sample, I have a few names and the corresponding sales. Let's see how Tableau gives ranks to these names depending upon its value of sales, right? Now, let me just connect this to Tableau, right? I will be connecting this to the rank sample, and we have our name and the corresponding sales just like we had in our rank sample. Let me bring it over here. We have our name and the corresponding sales in the text part, right? So we have the names and sales. Now let's apply the quick table calculation of rank, okay? Or you can also create a calculated field, right? Where you start typing as rank, you'll be able to view. We have one simple rank function. We have rank dense, we have rank modified, rank percentile, and rank unique, right? So we'll just make use of these different rank calculations, okay, in here in our calculated field itself, so that you'll be clearly able to understand or view the difference between these different types of rank functions, right? So first I'll just say I'll make use of the simple rank function, and I'm going to apply this rank function on my measure, right? And my measure is nothing but my sum of sales, right? So I'll just name this as rank, click apply, and okay. You can just bring this rank and place it in your visualization. We have our rank. Okay, it says first rank, second rank, fifth, third. Now, when you look into the value of sales, right?
Just a quick info, guys. Test your knowledge of Tableau by answering this question. What are the components of a dashboard? A. Horizontal. B. Vertical. C. Image extract. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
We have the highest value of sales, which has been given the first rank. Then we have the next least value, or the next, the one which is lesser than the highest value, right? The next lowest value, which has been given the second rank. Now, when it comes to the third rank, we have a tie. We have same value of sales, okay? And that is why the same rank has been given to both these names with the same value of sales, and the next higher rank is skipped, which means after third rank we should have had a fourth rank, which is skipped, and 20. Okay, now this might be given something around third rank. This will also be given the third rank. This will also be given the third rank, right? Now how will the next higher rank be skipped, right? So we will not have the fourth rank, we will not have the fifth rank, we will directly have the sixth rank for the next value of sales, right? So this is the rank function all about. We are just omitting, or we are just neglecting the next higher rank when we have a competition and when you make use of a simple rank function, right? Now let this calculation be as it is. Let me create another calculated field where I have the next rank function, which is rank dense. Okay, and in rank dense, I'll again say rank dense of sum of sales, right? Just click on apply and okay. When you bring in, I'll just try to rename it. This is rank dense, right? Let's see how rank dense handles combination. Handles the same value of sales, or handles competition, right? Now I'll bring rank dense and place it somewhere over here. I'll try expanding this. So we have the simple rank, and when it comes to rank dense, we have the first rank, we have the second rank, we have the third rank. When there's a competition, we have the same third rank, but instead of skipping any higher rank, it just moves on to the fourth rank, right? So it doesn't skip out any ranks, just as our simple rank function does. Okay, now that's a small difference between rank and rank dense. Then we also have the rank modified. Okay, let's see how competition is handled by rank modified, right? And I'll just name it as rank mod. Okay, click on apply and okay. Now you have the rank mod, which is a function, which is a calculated field that you have created. When you bring this into visualization, we have rank mod. Now it says first rank, second rank, and it straight away goes on to the fourth rank, right? So what happens under rank modified, the least rank is skipped and it straight away goes to the next higher rank when there's a competition, right? Now this is a small change. You can just compare this in contrast with our rank, simple rank function. It skips the next higher rank, whereas your rank modified skips the previous or the lower rank, okay, and then moves on with a higher value. So this is one small difference between rank function and rank modified. Then we also have our rank percentile. Okay, again, just like how we had our percentile values in our quick table calculation, when it comes to percentile of rank, when it comes to the rank percentile, values range from 0 to 1, right? So it says we have the least value of sales with a 0, the highest value of sales with 1, and then all the intermediate ones are split up are provided out of a total of 1. What is the contribution of this particular value of sales, right? And the last one that we have is the rank unique function, rank unique of sum of sales. Now as the name tells you, it gives a unique rank. Okay, even if there's a competition, it gives a unique rank to all my value of sales, right? I'll just click on apply and okay. Now when I bring in rank unique into my visualization, you'll be able to see we have first, second, third, fourth and fifth rank. Now for every value of sales, whether there's a competition or not, even when you have a competition, you will be given a unique rank. Okay, now for the same value of sales, okay, how does Tableau or how does this function has calculated a unique rank, which both have the same value of sales, which means which name has been given the highest rank. Now G has been given the highest rank because it first looks into the value of sales. Okay, if there's a match in the value of sales, it simply next moves on to the actual name. It just calculates the ASCII code of your name, and according to which your unique rank is given. Right now, when you look into the alphabetical order, we have G, which comes first, then W, and that is why G is given the higher priority, the higher rank when compared to the next alphabet, which has the very same value of sales, right? So this is how competition is handled by the different rank functions. Okay, we have rank simple rank, we have rank dense, rank modified, rank percentile, and rank unique, right? So the simple rank function skips the next higher rank when we have a competition. The rank modified function skips the least rank, okay, when you have a competition. When it comes to rank dense, there's no skipping of any ranks, okay, even if you have the same value of sales, even if you have a competition, okay, there's the same rank that has been given for both the value of sales, but there's no skipping of the higher or lower rank. But when it comes to rank unique, every value in your file will be given a unique rank. So first it will look into the value of sales. If there's a competition, it will simply go into the ASCII code of characters, and that is how the one which comes first in an alphabetical order is given the higher priority rank, and then comes the least rank, right? So this was all about the different rank functions that we have in Tableau. Okay, and with this, we are right after this, we are going to start with our LOD expressions. Level LOD, like LOD is nothing but the level of detail expression, right? Now, when it comes to Tableau, as I told you, this is considered to be one of the complex topics in Tableau, right? But still, once you grasp the concept behind this, I'm sure definitely this is going to be one of the easiest topics, right? So let's see what is an LOD expression, what are the different LOD expressions that we have in Tableau. Okay, now LOD is nothing but we are going to compute calculations which has complete independency from the view level of detail. Okay, now I'll tell you what is view level of detail. Okay, so this is the basic syntax. We have fixed, include, exclude. We have dimension 1, dimension 2, and then we have a colon, and we have an aggregated expression right over here. Okay, this is the syntax. Now, when you look into the diagrams, we have one diagram which is purely for exclude LOD expression, and we have another diagram for, that was for include, and this is for exclude. First, I'll explain what every diagram or every symbol in our in this particular diagram represents about, right? And yes, this is the diagram for include, and as you see, we have aggregation over here and we have granularity on this side. So aggregation is inversely proportional to granularity, right? Now, what is granularity? Breaking down one plot into different plots. Okay, we are making it granular in nature, right? After which, it totally depends. After which we will arrive at a raw data on which there is no aggregation that has been applied. Aggregation is nothing but the sum, the average that we apply on our measures. Okay, so an aggregation is inversely proportional to granularity, which means as you keep decreasing your aggregation, you will have a data which is more granular in nature. As you keep increasing your aggregation, you will have a data which is lesser granular in nature, right? So this is basically about aggregation and granularity. Then we have this dotted line over here, right? Now this dotted line corresponds to the view level of detail. What do you mean by view level of detail, right? For example, I'll just open up my workbook. Okay, now if I have category and let's say profit, now my view level of detail is nothing but what are the fields that are present right now in my view that corresponds to the view level of detail, right? Now category and sum of profit are the dimension and measure which fall or with which a visualization has been created, that is placed as or yes, so as I told you, this is the view level of detail. Now this dotted line corresponds to what fields are present in your visualization. Okay, and then we have a filled circle over here and we have a filled arrow mark. Now this filled circle represents a measure and this arrow mark represents a dimension. Okay, so here as per this diagram, we have the first filled circle which represents the measure called sum of sales. We have the next arrow mark which represents the dimension called country. Then we again have a circle, we have another arrow mark and so on, right? So I have an example with which we'll be discussing about include LOD expression in detail, right? And once we discuss about that example, we'll try connecting that example with this diagram and we'll see how the calculation has been carried out, right? And when we say include is our LOD expression, okay, we are including a new dimension, okay, with which a calculation will be performed, okay, and this dimension that you're including is not present in your view level of detail, right? So you are including a dimension with which a calculation will be performed, Okay, and that dimension is not present in your view level of detail, and the corresponding result of this calculation we will be brought back to the view level of detail so that the result can be viewed in your worksheet, right? So this is just like a cycle. You have a measure and a category, you have a measure and a dimension in your view level of detail. You are including a dimension which is not a part of your visualization but only a part of your calculation, and then you are displaying the result of this calculation, right? So this is general explanation of this diagram for include, right? Whereas when you look into exclude, we again have aggregation and granularity, we again have the view level of detail. Okay, but when you look into this diagram, there's a small change. The calculation when it comes to exclude is carried out above the view level of detail, but when it comes to include, the calculation is carried down the view level of detail, right? So I'll explain about these with appropriate examples, right? So we'll go back to our workbook. We'll just delete. Right. So now let me tell you, we'll start with our include LOD expression. Okay. Let's calculate the average of sales. Okay. Now I'll bring sales. Now you can place sales in your column, and then from this drop down arrow, you can change the way it is aggregated as average of sales. This is one option of how you can do this, or you can just instead of left clicking and then dragging your sales, you can right click on sales and then drag, place it in this space over here, after which automatically this dialog box appears and you can choose the way it should be aggregated from here itself, right? So we have our average of sales, and let's have our category, and let's have our subcategory, right? So we have the average of sales. Okay, we have the subcategories listed under every category, and we have the average sales of every subcategory that is getting displayed right over here. Okay, now what if I would like to compare the average sales of categories with the average sales of category in terms of subcategory? Okay, how do we do that? Okay, we will have to remove the subcategory. We will have to calculate the average of sales in terms of subcategory and then compare it with the average sales of category itself, right? Now you might have a small confusion of what is the difference between average sales of category and average sales of category in terms of subcategory, right? Now I'll try to complete the visualization first, and then I have a separate text file which is known as the LOD sample that I have. Okay, it is just something like a sample file of our superstore. Okay, so I'll explain how average of sales in terms of category is calculated and how average of sales in terms of subcategory is calculated, and why there is a change in the result between these two values, right? So as of now, we have our average sales in terms of categories. Okay, now I'm going to create a calculated field where I am going to calculate the average sales of subcategory, right? And I'm going to include the dimension called subcategory, okay, which is not present in my view right now. So I am including a dimension in the calculation that is getting performed. Okay, and this is the syntax. We have our keyword, we have our function or LOD expression name, which is include. Then we will have to specify dimensions that we are including in any calculation, and then we have our aggregated expression, which is nothing but the average of sales, right? So I'll just click on apply and OK. Now when you bring this sales of subcategory, which is a calculation, into your view, as you notice, the way your average sales is plotted is completely different. The values are, totally different. the sales of subcategories completely high when compared to the average of sales. This is because there's a second layer of aggregation that is applied on the result of your LOD calculation. So we will have to just change this into average. Okay, and now when you look into the tooltip, you have an average of sales and you also have average sales of subcategory, and we have different values for them. Right, now let's clearly go through every step behind how these values are calculated. Okay, and why there's a difference between the average sales of category and average sales of subcategory. Okay, and as I told you, I have a simple file for that. Right, so this is the LOD sample, the sample file that I told you. I'll be connecting this with Tableau, and I'll tell you, we again have three different categories. We have furniture, appliances, and technology, under which, for example, under the category called furniture, we have chairs, tables, beds. We have quite a lot of subcategories, and similarly under appliances we have around 2 to 3 subcategories, and under technology as well we have 2 to 3 subcategories. Right, now let's see, just like how we did in this workbook with sample superstore data, how to calculate the average of sales, how to calculate the average sales of subcategory using your include LOD expression, and what is the main purpose of making use of an LOD expression. Now we were discussing about LOD expressions, right? We have include, exclude, and fixed, and we started with include LOD expression. This is the LOD sample, as I told you. We'll try connecting this with Tableau, and I'll show you how I have an LOD explanation, LOD sample explanation notes as well. Okay, I'm sorry, this is taking a little time. It is a text file. This is my LOD sample that I'm going to open. Right, we have again category, subcategory, and their corresponding sales. Okay, now I'll bring the categories and let's have the corresponding sales value. Right, and when I change the aggregation, when I say I would like to view the average of sales, now this is how the average of sales is getting calculated. So first we'll see how average sales of every category is getting calculated. Right, and we'll look into this. I'll have this side by side. Right, now it says we have the total sales, which is 10,400. Okay, so when you just add up all the sales value, okay, when you add up all the values of sales in the column, in the field called sales, you will have a total of 10,400, right? Which means in our workbook, when you bring in sales into the text part, you'll be able to view the entire sum of sales, right? So this is the total value of sales, which is 10,400. Okay, and when you calculate the sales of furniture, we are just adding up the sales value right next to the category called furniture, whatever subcategory it might belong to. As of now, we are concerned only about the category furniture. So I'll just add these. I'll add the value of sales, which is under the category of furniture. So we are arriving at a result of 150. Okay, now average sales of furniture is nothing but the total value of sales 150 divided by the number of occurrences of furniture. Right, so furniture, whatever subcategory it might have, so furniture occurs 1, 2, 3, 4, 5 times in our data set, right? And that is how we calculate the average sales of furniture. Now when you look into our workbook, we have average sales of furniture, which is nothing but 30, right? Now this is the same way by which average sales of categories get calculated in our sample superstore as well, but I will not be able to clearly tell you the number of occurrences in this simple way that we just now did with this LOD sample, right? So that is why I thought I created a miniature or a sample just like our sample superstore, okay, with which explaining about this average of sales will be even better, right? So that is how we arrive at the average sales of subcategories, right? I mean, average sales of categories. Okay, now this is the value of average sales of sample superstore categories, whereas this is our average sales of our LOD sample. Okay, and we'll just go back to this. And similarly, we have the total sales of appliances. Total sales of appliances. So wherever you have appliances, you just add up the value of sales and you will arrive at this total value, which is nothing but 6,900. And the average sales of appliances is 6,900 divided by the number of occurrences of appliances. So you have 1, 2, 3, 4, 5, 6, and we have 7, 8 over here, right? That is why we have 6,900 divided by 8, which is 862.5, which is the average sales value of your category called appliances, right? And again, similarly, you calculate the average sales of technology in the very same manner, right? And we have arrived at this sheet. You can just have this as a bar chart if you would like to, or you can also have it as a text table, right? Now, what if I would like to compare this average value of sales, okay, with the average sales of in terms of subcategories, right? Now, how do we do that, right? Now, I'll just show you. Okay, so now when it comes to average sales of furniture, average sales of appliances, this is just the straightforward method of how average sales is getting calculated. Now, how do I calculate the average sales of appliances in terms of its subcategories, right? Now, there's a difference between both, right? This is just the average sales of that particular category, but this is the average sales of appliances in terms of subcategory. Okay, I hope you're able to get the difference between these two. Now, when I say in terms of subcategories, under appliances, I have two subcategories. I have TV and I have fridge, right? So I will calculate the average of fridge and TV separately, right? And then calculate the average of subcategories of appliances, and which will arrive at a single value. Okay, so I'm just calculating the average sales of fridge, which is nothing but under appliances. When you look into fridge, we sum up the sales of only fridge subcategory. Okay, and it occurs around 1, 2, 3, 4, 5 times. So 4,800 is the total value of sales only of the subcategory called fridge under appliances, right? So 960 is the average sales of fridge. Average sales of TV is nothing but, again, you calculate the sales value of only TV, and the number of occurrences, you divide by the number of occurrences and you arrive at 700, right? Now, therefore, the average sales of subcategories of appliances is nothing but average sales of fridge plus average sales of TV divided by 2, which is nothing but 830. So your average sales of appliances is 862.2, but your average sales of appliances in terms of subcategories is 830, right? So I hope you understood why there's a change between these values of calculating average sales of categories or average sales of categories in terms of subcategories, right? So basically, this is the concept behind the calculation that we are going to go through as an example for LOD include expression, right? So while discussing about LOD, it is always better to stick on to one example first. Okay, from the same example, just go through the very same example again and again, try to get the concept behind it, and then you can definitely try this out in any other example. Okay, so that is the one very important point when LOD is concerned about, right? So basically, this is the difference. We have average sales of categories, which is a different value, and average sales of categories in terms of subcategories, which comes up to a different value. Now, how will we arrive at this value? This is only by having average sales and category in our view and including subcategory in the calculation alone by using the include LOD expression, right? So now in this diagram, we have our average of sales, we have our category in the view level of detail. We are including the dimension called subcategory, where the average of sales will be calculated for the categories in terms of subcategories, and the result alone will be brought into our visualization so that you can compare between both the average sales of category and average sales of category in terms of subcategory, right? So basically this is what we are moving towards. This is the idea behind the calculation or the visualization that we are going to create. Okay, we are just trying to compare the average sales of categories with average sales of subcategories in terms of subcategories. Okay, and there's one more point. In order to bring the result of average sales of categories in terms of subcategories, we will remove subcategory from the view. Okay, we will create a calculated field which will include the dimension called subcategory, okay, which is not a part of my visualization. I'm including it only to calculate the average of sales, right? Yes, so this is the include LOD expression, and I'll just call this as sales of let's say subcategory, because it is in terms of subcategories, right? Just click on apply and OK. But when I try to bring this into visualization, okay, when I try to bring this into visualization, though there is already an aggregation called average that I have used in my calculation, okay, there is a second layer of aggregation that is applied to my calculation itself, okay, and which is by default the sum aggregation. I'll have to just change it as average, right? And now you'll be able to clearly compare between the average sales of categories and average sales of categories in terms of subcategories. Okay, and what is this second layer of aggregation all about? When you look into this diagram, we are performing the calculation in a space which is below the view level of detail, below this dotted line, right? Which means my view level of detail is more aggregated than the space where I am performing this calculation, right? So that is why, because my calculation is less aggregated than the view level of detail, when I bring back the result to the view level of detail, just to match the aggregation of my result with the aggregation of the view level of detail, I am applying a second layer of aggregation, right? When you just look into this line, this horizontal line over here, and this view level of detail, right? Your view level of detail is more aggregated, and when you move down to the space where your calculation is carried out, it is less aggregated when compared to your actual view level of detail. So that is why, in order to match the aggregation with that of the view level of detail, we are applying a second layer of aggregation on our result. Okay, only then it will be matched with the aggregation of my view level of detail, and the result will be displayed in the worksheet, right? Now there are two ways by which you can apply the view level of you can apply the second layer of aggregation. You can either change from this measure over here, okay, or you can simply edit this calculation. You can simply wrap up this entire calculation with a second layer of aggregation, right? So my entire include expression is wrapped up with an average aggregation. You can also try doing this. Anyhow, you should have two layers of aggregation. Only then your result that is calculated in a level which is lesser aggregated than the view level of detail will be matched with your aggregation of the view level of detail, right? These are a few points about include LOD expression. Okay, now we'll just go into our actual workbook of sample superstore. Yes, so we have our average of sales of categories, and we have average sales of categories in terms of subcategories. Okay, you can just look into the tooltip. We have different values for both of them because, I'm sure by now you must be able to get the point why the value of both these are different, right? Now we'll just try enhancing the visualization. Okay, now we are going to create a dual axis graph, dual axis chart. Okay, and in order to create a dual axis graph, we need to have two measures. Okay, and we'll be discussing in detail about dual axis graph during our next session. We'll be starting with the next module, which is about charts and graphs.
Just a quick info, guys. Test your knowledge of Tableau by answering this question. Which of the following is not a trend line model? A. Linear trend line. B. Exponential trend line. C. Binomial trend line. D. Logarithmic trend line. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
We have average sales of subcategory. You can customize, you can, enhance each and every chart, each and every graph, each and every measure. You can color them, you can change one into a bar chart, one into a line chart, just totally depending, how you would want your view, your final view to appear, right? So I'll just show you one example. As of now, I'm changing both the measures as bar charts. Okay, and we have our average sales, which is blue in color, and we have our average sales of subcategory, which is orange in color, but you are not able to find the blue bar graph because it is just overlapped. Both the bar charts, bar graphs are overlapping on each other, right? So because of which, let me reduce the size of this so that you'll be able to see the blue graph right behind it. Okay, now with this type of visualization, the user will be clearly able to compare between what is the average sales of category, which is the blue graph, blue bar chart, and what is the average sales of category in terms of subcategories, right? So that is why we have a orange bar chart over here, right? So you can easily compare them with this type of a visualization. This was one example where you can make use of LOD expression. You are calculating with a dimension which is not present in your visualization, right? You are including a dimension to your calculation which is not present in your visualization, right? Now exclude is just in contrast with this, right? Now just in contrast with include, we have our exclude LOD expression. We are, as you look into this, we have the filled circle, which is a measure. It is average of days. Then we have our first dimension, treatment category, and we have some other dimension called admit source, and then comes the view level of detail, right? Now from the view level of detail, okay, we are excluding a dimension which is already present in our view level of detail. We are performing the calculation without considering this excluded dimension and then displaying the result in the view level of detail, right? So we'll just look into that example as well. Let's say, for example, I have the state and city related sales, right? Now let's have the state. Okay, we have the list of states, and let's say we have cities. Okay, and let's have the corresponding sales, right? Now we have the state under which we have quite a lot of cities, and their corresponding sales is displayed over here, right? Now what if let's just sort this out in a descending order. Okay, so we get this over here, right? Now you can either use your state and city hierarchy as well for this, right? And now we are planning to compare the average sales. Okay, I'm sorry, I'll just change this into average sales. Instead of sum of sales, let's have average of sales, right? So now I have the average sales of cities, okay, that has been visualized over here. I would like to compare the average sales of state, okay, For every state, I would like to have a state average, okay, with which I can compare which cities has an average sales which is above or below the state average to which it belongs to, right? And how can I calculate the average of state when I have city in my visualization, right? This is where we make use of an exclude LOD expression, right? Just like this example over here, we have our average sales, we have our state, we have our city in our view level of detail, right? From which we are going to exclude a dimension. We are going to exclude city from our visualization. We are going to calculate the average sales of state alone and then bring the result to our visualization, right? Now let me just visualize it, and then when we arrive at the final visualization, you'll be clearly able to understand, right? So I'm going to create a calculated field. This, I'll just name this as state average. Okay. I'm going to exclude a dimension. Now you can, when you are including a dimension, you can include any dimension of your choice, whatever is present in your data set, right? But while excluding, you will have to make sure you will have to exclude only the dimension which is already present in your visualization, right? So that is one important point when it comes to exclude. So here we are excluding the dimension, which is nothing but the city, and my aggregated expression is average of sales, right? I'll just click on apply and OK. Now this is the state average. You can simply bring the state average and place it into your visualization. Now there's one point. When we try to bring the result, bring the calculation into our view in our include LOD expression, okay, we had to either apply a second layer of aggregation, or we had to add two layers of aggregation. We had to wrap up the entire include expression or with an average aggregation, which is the second layer of aggregation, right? But when it comes to include, what is supposed to be done? I'm just bringing state average into my view, right? And yes, I have the result that is getting visualized. This is because, as I told you, when it comes to include, the calculation is done in a space which is in a lesser aggregated area than the view level of detail. That is why, while bringing the result back to the view level of detail, in which is more aggregated in nature, we had to apply a second layer of aggregation, right? But in contrast, we have our exclude calculation that is done above the view level of detail, above this dotted line, which means the calculation is getting performed in a space which is more aggregated than the aggregation of the view level of detail, right? That is why when it comes to an exclude LOD expression, okay, because the result is already in a more aggregated area, there is no need to apply a second layer of aggregation. You can simply replicate the result in the view level of detail, right? You can just compare these two diagrams. The calculation is below the view level of detail, and here the calculation is above the view level of detail because we are excluding a dimension which is already a part of the view, right? So that is why the calculation is done above the view level of detail, and instead of applying a second layer of aggregation, there's no use of applying a second layer of aggregation. You can just replicate the result to be visualized in your worksheet, right? In your view level of detail. Okay. Let me go back to the workbook. I have brought the state average. We haven't applied any second layer of aggregation. We are just replicating the result over here. Okay. It says attribute because you cannot, further apply any aggregation on top of this, right? Now let's enhance the visualization. Now we have both as bar charts. Okay. I would like to have the state average to be displayed as Gantt bar. So under state average, I am choosing the Gantt bar from the marks card. Okay. And let me create and let me change the color of it first. Let's have a lighter color, something like this. Okay. And let me create the dual axis chart, right? And I would like to have my average sales of cities as a bar chart itself, right? Now let's try synchronizing the axis, right? After which we have our average sales of cities, and we have the average, the state average that is represented using a Gantt bar. So by this, you can clearly be able to find out which particular city has a sales which is lesser than the state average, or whichever is higher than the state average, right? You can also label them. You can also change the color of your bar chart. Let's say I would like to have this as light blue and orange. Okay. And you can also label them. You can simply bring your sales with a right click on your label and have it as an average of sales. Okay. And when you click on this label, you can decide on your alignment options. Okay. I'll just place it in the center, right? And then you can also label your state average, right? So with which you can easily compare whatever is your state average and whatever is your city average in one single chart, right? So this is an example of exclude LOD expression. We are excluding a dimension which is already a part of our visualization, performing the calculation with only the dimension that is left out. Okay, and then we are displaying, we are just, instead of applying, there's no need of applying a second layer of aggregation. We are just replicating the data in our view level of detail, right? So this was about include and exclude. So I hope you're able to compare both the differences between these two, right? And we just have one more to go, which is nothing but the fixed LOD expression. But when it comes to a fixed LOD expression, calculations are computed independently of what data is present in my visualization. I might have any dimension in my visualization, right? But the result of my calculation will remain fixed, right? So let's just look into an example for that. Let's say I would like to see which are the customers who are profitable and which are the customers who are not profitable, right? Let's say I'll bring in the customer name into rows, and let me bring in the sum of profit. Okay. Now, when you look into this profit, we have a few customers with positive profit and we have a few customers with negative profit, right? So now let me just create a very simple calculated field, right? I'll just call this as color. Okay. I'm going to just say sum of profit is greater than 0. So there'll be two different colors, one for the value of sum of profit greater than 0 and one for the profit value which is lesser than 0, right? So I'll just click on apply. Okay, and I'll place this into the colors mark. So now as you notice, and I'll just change true to be blue and false to be orange. Click on apply and okay. So here we have, you can also sort this out in descending order. So these are the list of positive customers, and as you go ahead, you'll have a list of negative customers, right? Which we have a different color code for the positive or profitable and non-profitable customers, right? But this doesn't answer any such analytical questions, right? As of what is the number of profitable customers, like let's say per city or in any state, in any particular state, what is the number of positive profitable customers and what is the number of negative or non-profitable customers, right? So how do we do that? So in order to answer such analytical questions, we will have to make use of our LOD expressions, right? And let's see how that can be done. Okay. Now you can also bring in city over here, okay, where you have whether this particular city has a positive profit or not, this particular city has a negative profit or not, right? But in this same chart, I would like to view the number of customers in any city who are profitable and not profitable, right? So let's see how this can be done. I'll just clear the sheet. Okay. Now let me create a calculated field, right? So whatever dimension is going to be placed in my visualization, this calculation is going to remain fixed. Okay. I'll just say fixed. I'm sorry. I'll just say fixed. And I'm going to fix the customer name over here because I would like to view the fixed count of customers, okay, in terms of whether they have positive profit or negative profit, right? So we are simply specifying a condition right here in our LOD expression, okay? So we have our sum of profit, which is greater than 0, and customer name. Okay, I'm sorry, I just didn't name my calculation. Okay, so this is it. We have our fixed customer name. We are fixing the dimension called customer name. Okay, and we are just calculating whether the customers have a positive profit or a negative profit, right? So this is the result of this calculation, and we'll just name it as, let's say, profitable customers, right? So we have this calculated field. Just click on apply and OK. So we have profitable customers. Yes, they are profitable customers with a profit greater than 0, or no, true or false value. No, they have a negative profit, right? Now let me just let's say bring in customer. Okay, I'll bring in cities. Okay, let's try calculating the count of customers in terms of cities. We'll have our cities in rows. Okay, and now let's put this calculated field called profitable customers. Okay, and while putting this into our columns, we will have to have a count distinct, or you can have a count aggregation. I think count will be fine, right? Let's have a count aggregation. Only then you will get a count of profitable or non-profitable customers, right? So as of now, we are able to view, we have a count of profitable customers as 355. The count of customers are clearly viewed over here. Okay, now let's try to make it even more clear. Okay, let's try to make it even more precise, and I'm creating another calculated field. So I'll just complete the visualization, and we'll come back to the different calculated fields that we created, and we'll just go through what is the advantage, what is the purpose of every calculated field, right? So now I'll just call this as profitable, whether this is profitable or not. We are just going to differentiate between them, right? So I'll just say if the result of my calculated field called profitable customers is equal to true, right? Then, right? So if the result of my calculated field called profitable customers, which makes use of the fixed LOD expression, is true, which means if the sum of profit is greater than 0, right, then they are profitable, right? Else you can just say they are non-profitable, right? And you can simply end your calculation, right? After which we will just click on apply and OK, right? And now let's just place this profitable into the colors marks card. Okay, and I'll just change this. I want profitable to be blue in color, and I want non-profitable to be orange in color, right? I'll just click on apply and OK. Now for every city we have a blue mark and we have an orange mark, right? So it says blue corresponds to profitable customers, where the count of profitable customers is 300. When you click on orange, it is the count of non-profitable customers, but it says count, the tooltip has to be enhanced, right? But as of now, this is the count of customers who has negative profit in this particular city, And this is the count of customers who has positive profit in this particular city, right? Now let's try enhancing the enhancing the tooltip. Okay, as of now, I don't think the tooltip is fine. Now let me just click on tooltip. Okay, I'll just remove this. I'll just have it as count of profitable customers. So these many customers, okay, you can just insert city from here. In this particular city, okay, your tooltip is going to be dynamic in nature, so it will automatically display the city wherever your cursor has been placed. So these many customers in this particular city are whether they are profitable or non-profitable, right? To display that, we will make use of this calculated field, right? Just click on OK. And now when you look into the tooltip, it says 300 customers in New York City are profitable. So as an audience or as a user, they will be clearly able to understand what analysis you have made right from the tooltip that you have created, right? Or it says there are 50 customers in San Francisco who are non-profitable, right? So it clearly tells you from the tooltip itself, the users will be able to understand. And as we had made it dynamic, the name of the city also is getting updated according to wherever we place the cursor, right? And blue means it is profitable and orange corresponds to the non-profitable customers, right? Now, why do we say this calculation is fixed? Whatever dimension is placed in your visualization, or this calculation is computed independently of whatever data is present in your visualization. Why do we say that? Now we have our city related information. Now I can just simply replace city by state. You just have to place state right on top of city. Okay, and as you notice, for example, in California, the tooltip has also been updated accordingly. Instead of city, we have the state in our tooltip. Okay, you have the information that 473 customers in California are profitable and 104 customers in California are non-profitable, right? So whatever dimension I bring in my view, the result of this calculation is just going to remain the same. The result of this calculation is just fixed as it is, right? You can also try bringing any other dimension, let's say subcategories, right? You might be able to see these many customers in this subcategory are profitable and these many customers in this subcategory are non-profitable, right? And you can also you can also label your visualization. Okay, I'll bring this count of profitable customers in the label part with a count aggregation, right? After which you'll be able to see, you can just expand this a little bit. You'll be able to see you have the exact count of customers right here in your bar chart itself, right? So this will allow the user to, very easily view your chart and, get to know what analysis you have made, right? So this is about the fixed LOD expression. Your calculation is computed independently of whatever data might be present, whatever dimension you might use in your visualization, right? So this is all about our LOD expressions that we have: include, we have exclude, and we have fixed LOD expression. Next topic called LOD calculations, about how to fetch the latest 3 months details or 3-month data alone, right? So I'll create a new sheet. Now I'm going to bring in my order date. Okay, let's have it in terms of continuous months. Okay, and please note, I have first converted it into a continuous date field, okay, in terms of months, and then I am changing it into discrete, right? This is because I would like to have a text table in this manner which has continuous month details, but the values should be displayed in a discrete format, right? So I hope you understood how we arrived at this. I have my ordered date in terms of continuous months, where I have every month name, a plot for every month, right? And after which I'm just changing it into discrete so that I'll be able to get this as a text table. I'll be able to make use of this as a text table, right? Now let me bring in the sales and place it into the text part, right? So this is our continuous months in a discrete format. Okay, now as of now, the latest month is December 2018, November 2018, and October 2018, right? Now let's try to fetch out only the latest month, okay, which is December 2018, right? Let's see how that can be done. I'll be creating a very simple calculated field, right? I'll just call this as latest month sales, right? We'll call this as latest month sales because it is going to fetch only the sales of the latest month. And as our data is concerned, we have December 2018, which is the latest month, right? So for that, I'm going to make use of a few date functions, right? So now let's see how that can be done. I'll just say I'll make use of the if logical function. If I'll just complete typing the calculation, right? And then I'll let you know what is being done over here. Now we are calculating the date difference in terms of months, okay? And between, I'm just trunking the date to the month level, okay? And this details is to be fetched from the field called order date, okay? And after which, I mean, when it comes to date difference, we should have a date part, okay? We should have a start date and an end date between which the date difference will be calculated, right? So when you look into this, okay, so we have the date difference in terms of month, the date part is month, right? Now the starting date is the date trunk. I'll tell you what is date trunk about, okay, right? In terms of month, and then I'm going to
Just a quick info, guys. Intellipaat provides Tableau online training and certification course mentored by industry experts. The course link of which is given in the description below. Now, let's continue with the session.
calculate the max of date trunk. Now, what is this all about? I'll just let you know. I'll split this up into 3 and I'll explain the result, what every single function is going to display, right?
Just a quick info, guys. Test your knowledge of Tableau by answering this question. What are the components of a dashboard? A. Horizontal. B. Vertical. C. Image extract. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
We have month as the date part again, and we have the order date from which the corresponding details are to be fetched, right? And after which we have, I'll just make sure the curly braces are fine, right? Yes, now when this is equal to 0, then you can display the sales, else end it, right? Date difference, we have month to 1, 2, 3. Okay, I'll just close the date difference over here. I think this should work fine. Yes, right. So we are just calculating the difference between 2 dates, right? In terms of in the month level. Okay, so I am the result of this date trunk in terms of month level of order date. So this is the starting date, which is nothing but for every month we will have this value that is displayed, okay? And then this max of date trunk, now date trunk month of order date, okay? The max of date trunk month of order date is going to be 12. right? Because the maximum month that we have in our, the latest month that we have in our data set is 12, the month of 12 of 2018, right? So that is why we will have the month of 12 of 2018 over here. So when you find a difference between them, right, only the December month details will have a value of 0 when you calculate a difference, right? All the others will have a different value. For example, November will be something like 10 minus 2 or 12 minus 2. 12, which is the max of date trunk, minus 10, which is the number for October, which is nothing but 2, right? So the value is not going to be equal to 0. So only when it is equal to 0, we will be able to fetch the latest month details. Just click on apply and OK. So we have our latest month sales. Drag this latest month sales simply here into your visualization. Right now, as you notice, we have the actual sales, and when it comes to the latest month sales, we have only the latest month, okay, which is December 2018 value of sales that is displayed in this space. Right now, similarly, you can calculate, you can just create a calculated field for let me just create a duplicate of this, okay, and I'm going to edit this. I'll name it as, let's say, previous month sales, okay, and here I will have the value as 1, okay. So now max will be 12, okay, and only when it is November we will have 12 minus 11, which will where the value is going to be 1, right? So just click on apply and OK. When you bring this into the view, you will have the previous month sales, and similarly you can also calculate the prior month sales, okay. Just try duplicating this. You can edit this, have this value as 2, and then you can just name this as prior month sales, which is going to display the sales of the month of October, right? So this is how you fetch out every latest month details as per your requirement, okay. Now let's say you can just simply remove sales from your text part, okay, and you can remove month from your rows, right, where we have only the latest month, previous month, and prior month sales, right? You can bring in measure values and simply place it into your rows so that we get a bar chart for the latest month, previous month, and prior month, okay. And you can also label them if you require. Just bring in this calculation and label them, or you can just click on this, after which the label option, the text option in your toolbar, right, after which your bar charts will be labeled, right? So this is the latest month, previous month, prior month, and this calculation will be done according to whatever data is present in your data set, right? So this will get updated as your data set increases, your data is getting added to your data set, right? And also for having latest 3 months together, right, you can just say a value, you can just change your calculation as, instead of equal to 2 or equal to 0 or equal to 1, you can just say anything which is less than or equal to 2, right? After which you will be able to, let's try doing that. I'll create a new sheet, right? Let me just create a duplicate of this and I'll try editing this, okay? And in this calculation, let me just remove, we'll remove the condition. Let's have only the date difference, and let's also remove this, and let's change this to be lesser than or equal to 2, right? And just click apply and OK. Now you can I'll just rename this. You can have it as latest 3-month sales, right? So we have our latest 3-month sales, okay. You can bring this, let's say, into your view, okay, where you have true and false values. Now, okay, now let me just bring in order date, okay, and their corresponding sales over here. Let's change it into a bar chart, okay. You can also have it in terms of continuous months, right? Or you can also change this to be discrete so that you have a separate bar chart, right? Now, when you let's say, let me bring this latest 3-month sales into the filter first, and I would like to view only the true values. Click on apply and OK, after which only the latest 3 months values will be displayed, right? So this is just displaying all the 3 months values together in one view, okay? So this was just an example of LOD calculation. This is not an LOD expression. This is an LOD calculation, a calculation which will be carried out independent of what change is being made to your data or what is present in your visualization, right? So this was all about LOD expressions, LOD calculations, about the inbuilt functions and calculations that we have in Tableau, right? Yes, we are going to start with charts and graphs. Now, this is again one important topic because it really matters. Whatever analysis you have made, you will have to represent, you will have to visualize it with an appropriate chart, okay, as per analysis you have made, right? And only then your chart, your visualization, whatever analysis you have made will reach the audience in a better manner, right? So we have various types of charts and graphs that you can make use of in Tableau in order to visualize your data. Now we have around 24 types of charts and graphs, which is readily available right here under Show Me, right? And we also have a few other types of charts and graphs that can be created, right? Let's start with the dual axis graph, right? Or a dual axis chart. Let's see how to create that, right? As the name tells you, we have dual axis chart or graphs. It means you need to have two axes, right? Which means you need to have two measures. So only when you have two measures, you can create a dual axis chart, right? Let's say I have my order date, and let's say we have two measures. We have sales and we have profit, right? So now we have a separate axis for sales and we have a separate axis for profit. Now, if I would like to compare both these measures under one graph or in one graph, how do we do that? Now, this is where we go into the dual axis graph or dual axis chart, right? As I told you, we need to have two measures in order to create a dual axis graph. Now, when you click on the drop down arrow of your first measure, you do not have an option called dual axis, right? Only on your second measure, when you click on this drop down arrow, you have an option called dual axis, right? So let's create a dual axis. So now automatically we have a color code. We have a separate color for sales and we have a separate color for profit, right? But again, we have sales and profit, and the way, yes, exactly, so we will have to synchronize the axis, right? So we have the values, the way your graph, your axis appears is different for both. So we will have right click on any axis and you will have an option called synchronize axis, after which both the axes will get synchronized, and you can just remove the header, you can remove one axis, and now we have our sales and our profit plotted in the same graph with just one axis, right? And you can also notice there's a structure change in between these two pills, right? So there's a straight line with which these two pills appear, and this indicates that you have created a dual axis between these two measures, right? Now, what if I would like to have one more measure? What if I would like to compare, let's say, the sales, profit, and discount of this particular superstore in a single graph, right? How do we do that? Now, let me bring discount, which is again a measure, and place it right next to profit in rows. Okay, So now we have already created a dual axis chart or graph for sales and profit. Now let's also try including discount in this graph, right? Now when you click on this drop down arrow, you do not have the option called dual axis because, as I told you, a dual axis graph can be created only between two measures, right? Then how do we include a third measure, or how do we compare more than two measures in the same graph, right? Now this is where we make use of the measure names and measure values, right? So let's remove these measures. Okay, let me bring in the measure values, okay, which is an auto-generated field under measures. I'm just placing this measure values into rows, and after which all our measures, all the fields under measures, we have discount, we have number of records, profit, quantity, and sales. All these measures have been plotted out in our graph, and just to differentiate between these, I would like to bring measure names and place it into the colors mark, after which every measure name has been given a unique color. Okay, and now I can simply filter out. I would like to view only discount, profit, and sales in my graph, in one particular graph, right? I'll just click on apply and okay. So now you have only your sales, your profit, and your discount, which has been plotted in a single graph, right? So when you would like to compare, or when you would like to plot two measures into the same graph, you can go in for a dual axis option. When you would like to compare or visualize more than two measures in the same graph, you can make use of the measure names and measure values, by which we can create a multi-axis graph, right? So this is how you create a dual axis graph and a multi-axis graph using your measure names and measure values, right? So now this dual axis option can also be used to create dual axis maps, right? You can also combine two maps and display the information on two different maps in a single map using your dual axis option, right? And we'll also be looking into how to create a pie chart and how to create a donut pie chart, where again we'll be making use of this dual axis option, right? So basically, in order to create a dual axis chart or graph, you need two measures, and only on the drop down arrow of your second measure you will have the option of dual axis, right, with which you can combine, you can visualize both these measures into the same graph, right? So this was about the dual axis graph. Next we have, you can just look into the show me. You have different types of text tables, heat maps, highlight tables, pie charts, and so on. And you have the requirements for every type of chart or graph, right? So we'll just go through a few. We have a dual combination chart, or we also call it as a Pareto chart or Pareto chart, however you pronounce it, right? Now, as say dual combination, you have two different types of charts combined into one, right? Now, let's say I have my, again, let's have our date, and let's have both our measures, sales and profit, right? So under show me, so these are the different options that you have for this combination of one dimension and two measures, right? So now let's look into this option. So we call this as the dual combination chart, right? So one measure has been plotted out using a bar chart, and one measure has been plotted out using a line graph, right? So this is how, and automatically you have this dual axis chart that has been created between these two, right? Now this is a readily available option which is available, right? And you can also do this manually. For example, you can bring in your order date, you can bring in your sales, and let's say your profit. And when you look into this marks shelf, you have three options, so three different tabs. You have all, you have sum of sales, and you have sum of profit, right? So now this is, you can, we use Pareto. Yes, okay, yes, that is one type of chart that you can make use of. Yes, so as I told you, for comparison we use Pareto. Yes, exactly. Yeah, now when it comes to your marks shelf, we have separate tabs for all. Now this simply means when you, let's say, change the size, or decrease the size, automatically both your graphs will correspond to whatever changes you make under the all tab, right? When you click on sum of sales, only your sales line graph will act according to the changes that you make in this space under your sum of sales. Right now, let's say I'm changing this into a bar chart, or you can have it as a circle mark, right? So only your sum of sales graph will correspond to whatever changes you are customizing using this tab, using these options under sum of sales. And the same with sum of profit, right? I would like to change the color, so only this particular line chart which corresponds to the profit will reflect the corresponding changes, right? So this was just one point. When you go in for a when you have two measures, you have separate options, separate marks cards which are available for each measure, as well as a generalized marks card which is available for both your charts, right?
Just a quick info, guys. Intellipaat provides Business Intelligence Master's Program in partnership with Microsoft, the course link of which is given in the description below. Now, let's continue with the session.
And I have my corresponding sales. Right now, by default, whenever you have one measure and one dimension, it is automatically a bar chart that gets created, right? So this is the first combination. Now, what happens when I have one date dimension and one measure, right? So it is automatically a line chart that gets created. When you have, it might be in any order, it might be you might have a measure in rows and a dimension in columns, or just the other way around, it doesn't matter. But for a combination of date dimension and a measure, it is always a line chart that gets created. You can very well go ahead and change it into a bar graph or any type of chart as per your requirement, but automatically for this combination of one dimension and one measure, it is a line chart that gets created. Right now, similarly, you have, let's say, two measures. When you have two measures, you have the shapes marks card that comes, that is automatically used under your marks shelf, because it is a scatter plot chart that gets created when you go in for two measures in your visualization in your row and column shelf, right? And similarly, when you have two dimensions, let's say I have my subcategory and category, okay, it is automatically a text table that gets created for the combination of two dimensions in your row and column shelf, right? So we have a text table when you have two dimensions, you have a scatter plot chart when you have both as measures, you have a bar chart when you have one dimension and one measure, and you have a line chart when you go in for one date dimension and one measure, right? So these are a few basic points. As you start using Tableau, definitely you'll be getting to know all these in the flow, right? So this was just for information about what type of chart gets created automatically for the different combinations with which that you bring into visualization, right? So as I told you, you have we just had our region and sales. Okay, by default, it is a bar chart that gets created, but I can also go in and create a line chart. Okay, and and you can also have a date line chart. Hierarchies, when you make use of a date dimension for which Tableau itself has created a default hierarchy, you can just go ahead. You can have a separate line chart for every year or for every quarter, okay? Or you can also change it into a continuous year, right? We'll have it as a continuous year with the measure, after which you have a line chart for it, and then you can, keep going ahead in terms of your continuous date field, right? So now there are a few differences between using a discrete date field and continuous date field, right? So this is basically how each discrete date field and continuous date field act when you try to visualize data using these date fields, right? And you can also, let's say, bring in categories or any dimension in the colors mark, after which you will have a separate line chart for every category, okay, that you have in your data set. Or you can also bring in region, right? So you have a separate line chart depending upon the sales in a continuous month format for the different regions that you have in your data set, right? So this is how you color your line charts. This is known as a colored line chart, okay? So these are the different options with which you can go in for a line chart, right? And next we have bar chart, right? So again, bar chart is something that we've been using. Let's say we have our subcategory with the corresponding sales. Now this is a vertical bar chart. You can just swap your pills to create a horizontal bar chart, and you can just place in, let's say, ship mode or any dimension, after which you are creating a colored bar chart, right? Now this becomes a colored bar chart, and you can just, let's say, I'll show the filter for the dimension category, and this becomes an interactive bar chart because you're interacting with your bar chart, okay? And then we have something called as a leveled bar chart. Now when I bring category also into the view, we have a separate pane for every category under which the corresponding subcategories are placed, right? This is known as a leveled bar chart. So basically we have the horizontal vertical bar chart, we color our bar charts, we make it interactive, and you can also have such bar charts known as leveled bar charts. Now when you click on your sorting options, there's a sorting that takes place for every category, okay? So yes, now these are again a few options while creating bar charts. Next we have pie charts. I'll just show you. When you have two measures, it is a scatter plot chart that's created, and I would like to split this plot into, let's say, I'll have different subcategories. You can place it into the details mark, right, by which the same shape has been given for all your subcategories, or you can also place it into the shapes marks card, okay, after which you will have a separate shape that has been given for the members in your dimension called subcategory, right? Now this is again called the shape legend, okay? Just like we have our color legend, this is known as, we also have our size legend, and this is known as the shape legend. It is just a key which indicates that for which particular shape, which category belongs to which particular shape. And as you notice, we have repeated shapes over here because, this particular palette that we are using consists of only around 10 different shapes where we have 17 subcategories. You can just go in and choose from the set of palettes that are available, right? You can make use of these arrows, right? Or you have these thin arrows or weather related shapes, right? So these are a few options that you can make use of, okay? So this was about the scatter plot chart and how you can make use of the marks card, the shape card in your marks shelf, okay? This was about the scatter plot, and you can again make your scatter plot chart colored or interactive, right? And we also have the option called drop lines. Now let me bring in subcategory into detail. And now when you click on any one plot, okay, when you just right click, you have this option called drop lines, right? I'll just say show drop lines, okay? And again, when you right click on any plot, you have an option called edit drop lines. Now these are lines dropping from any plot that you select, right? Your lines drop both to your x-axis as well as to your y-axis, and you can just customize them. I would like my line to drop only to x-axis, okay? And I would like the line to be dropped always, and not only when I select, but I want the line to be dropped always. The line is supposed to drop to x-axis, right? Just click on OK. After which, for all the plots in your graph, there's a line which is dropping to x-axis. Now this doesn't exactly show where your line is dropping or what value in which your line is dropping, right? You can also customize that. Let's say I'll go in for only when selected, right? And I would like the line to drop to both to x-axis and y-axis, okay? And I would like to give an automatic label as well, right? Now when you click on OK, now only when I select any plot from my graph, right? Let's say I'm selecting this plot. Now there's a line dropping to both x and y axis, as well as we have the value that has automatically appeared at the end of the line. So with this, we can clearly identify what is the exact value this line is dropping at, or between these what values this plot has been plotted out, right? So this is just for your convenience. When you go in for a presentation, you can just have such drop lines. So whenever you click, you select any particular plot, you will have lines dropping, you will have the exact value where on which your line is dropping for this particular plot, right? So this is what drop lines are all about. And next we have the bubble chart. So when you look under show me, you have packed bubbles. Okay, you have one or more dimension and you need one or two measures in order to create a bubble chart. Now let's say we'll have categories and we have the corresponding profit, right? And as I told you, by default, with a dimension and a measure, you have a bar chart that gets created, right? But when it comes to packed bubbles, we will have to go into show me and then select packed bubbles. Now this is how a packed bubble chart looks like. You have circles and you have a number of circles and you have the size of circles. Now the number of circles is decided by the dimension, right? Because the number of values, the number of members in your dimension decide the number of circles, okay? And the value of your measure decide the size of every circle, right? For example, I have my subcategory. You can also create a chart by simply clicking on one dimension, press Control from your keyboard, click on any other measure, and then go into show me, after which you will be able to see what are the different types of charts that can be created with this combination of one dimension and one measure, right? Needn't have to bring them into the visualization and then create a chart. You can just click both, any of your dimensions and measures, and then go into show me and select that particular chart, right? So we're under subcategories, we have 17 subcategories, and that is why we have 17 circles right here in our bubble chart. Okay, and the size of every circle is decided by its value of sales, right? So we have phones with the greatest value of sales, and that is why phones is having a larger circle compared to all other subcategories. Now there's one limitation while going in for a bubble chart, right? It is always better to avoid going in for bubble charts with dimensions having more data, right? For example, if I would create a bubble chart for customer names, right? I have quite a long list of customer names. Now, when I go in to create a bubble chart for customer names with their corresponding, let's say, profit or quantity or sales, okay? Now, this is how your packed bubble chart appears. Okay, it just forms a cluster. We are not able to clearly identify or analyze any information as such from this type of a graph, right? So it is always better to avoid using packed bubbles when you have more data. But when you have a limited number of members in your dimension, you can very well go ahead. Let's say, for example, ship mode and its corresponding profit. You can very well make use of packed bubbles, right? Where the number of bubbles is decided by the dimension and the size of bubbles is decided by your measure, right? And this was about the packed bubbles chart. We also have tree maps, okay?
Just a quick info, guys. Test your knowledge of Tableau by answering this question. Which of the following is not a trend line model? A. Linear trend line. B. Exponential trend line. C. Binomial trend line. D. Logarithmic trend line. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
When I click on tree map, you have technology, office supplies, and furniture, right? When it comes to tree maps, as I told you, it is very similar to a packed bubble because the number of boxes, it might be a square or a rectangle, the number of boxes in this tree map is decided by your dimension, right? So under the dimension called categories, we have 3 different categories. So we have 3 different boxes, and the size of each box is decided by the sales or whatever the profit, right? So profit is our measure over here. Whatever is your measure, depending upon the value of that measure, your size, the size of your box is decided, right? So again, as I told you, the number of boxes is decided by the dimension and the size of each box is decided by your measure, okay? And when it comes to tree maps, the main visual element of tree map is known as, it is also known as a space filling display, right? So when you notice, we have only 3 members in this dimension called category, but still the entire space in our worksheet has been occupied by this tree map, right? Or let's say I would have subcategory wise sales for which I'm creating a tree map, right? And even then I have the entire space in my worksheet that is occupied, right? Now this is why we call tree maps as a space filling display, because it occupies the entire space in our worksheet. And in this example, we have our subcategories. We have 17 subcategories. So the number of boxes is equal to the number of members in your dimension. And the size of each box is decided by your measure, which is nothing but sales in this particular example, right? And I'll just show you. Let's create a hierarchy. Let's say I have my country and my state, right? I'm just creating a hierarchy for this. And let's try using this hierarchy and create a tree map, right? As I told you, we only have one country called United States under the dimension called country, right? Even then the entire space is occupied in my worksheet, right? And when I drill down, so under this particular country, we have so many different states for which a tree map has been created. So you can also make use of hierarchies while creating tree maps, okay? And this is one important point. It is known as the space filling display. It is the only chart which occupies the entire space, no matter what measure or what dimension you make use of to create a tree map, right? And again, when it comes to tree maps, you can have an interactive or a colored tree map, right? So any chart for which you simply create a quick filter, that becomes an interactive chart, okay? And you can also color them out. Let's say, for example, I'll bring a category into the colors marks card, after which your tree map has been divided into 3 different colors depending upon whichever category your subcategories belong to, right? And you can make it interactive in nature using your quick filter, right? So this becomes an interactive tree map as well as a colored tree map, right? So this was all about tree maps. And then we have pie charts, right? So now let's see how to create a pie chart and what are the different options and what are the different types of pie charts that you can create in Tableau, right? Now you can simply click on one dimension. Let's say we'll have a region and the corresponding sales. Okay. And under show me, you can go in and create a pie chart, right? Or this is one way by which you can create a pie chart, or you can simply, let's say, drag in categories, the corresponding sales, and under your marks, in your marks shelf, you can choose your pie marks card, right? After which you will have a separate pie that gets created for every single category, okay? Or you can simply bring in the sales value and place it into your visualization, right? And then choose pie from your marks card, for which a pie chart has been created for the entire value of sales, right? And then you can bring in any dimension in your colors marks card, right? So these are a few ways with which you can go in and create a pie chart. Okay. And now let's see what is a donut pie chart all about. Okay. And when you would like to create a donut pie chart, we need to have two different pie charts that is combined together. Okay. Now, why do we call it as a donut pie chart? Because it resembles a donut. Okay. I'll just try and visualize. I'll visualize and then let you know. You'll be able to clearly get the point why it is known as a donut pie chart. And in order to do that, we will have to combine two pie charts, and combining two different charts is done with the dual axis option that we have, right? And in order to create a dual axis chart, we need to have two measures, right? Now we will be making use of, let's say, the number of records. Okay, this is an auto-generated field, and we'll be making use of number of records twice in our visualization. And this is just for creating a donut pie chart, right? So because we need two measures to create a donut pie chart, we are going in for this measure called the number of records with an attribute aggregation, right? Which means it cannot be partitioned further, right? Or it cannot be, you cannot partition the data, right? So we'll just quickly look into that. We'll have our number of records and I'll have it as an attribute, right? Then again, we'll have our number of records. You can either go in for a dual axis chart, or you can also change it into a pie, okay? And then go in for a dual axis option, right? Where you can just decrease the size, right? Fine. And my first, I'll just change the color. Okay, why is my color not changing? Right. So I've just changed the color of one of my, number of records, one of my circle, right? And let this be blue in color. And then I'll try increasing the size, or I'll try decreasing the size for the second number of attributes, right? So you just have to first make sure which circle corresponds to which number of records, right? Whichever, I mean, both will be overlapping on each other. So you'll just have to make sure which circle corresponds to which number of records and then make the necessary changes, right? So I'm just decreasing its size. I think this looks better. Now this resembles a donut, right? That is why we basically call it as a donut pie chart. Now let's have, yes. So yes, this resembles a donut. And now let's try adding details to it. Now in my second circle, which is the inner circle, okay, I've just given it to be the same as the background color, just to resemble a donut. Okay, I'll just make sure it's my second circle. Yes. Now in this second circle, I'm going to place my entire value of sales. Okay, and in my outer circle, I can place any dimension, right? For example, I'll bring my categories, place it into the label part, right? And categories, and place it into the colors part, after which you have a separate color that you have given for every category, and you have the entire value of sales. And you can also bring in sales and place it into the label part right next to every category, right? So this is how you create a donut pie chart. Now this is just for visualization purpose that we are making use of number of records. Okay, and this is just another way that you can make use, that you can use to visualize, to represent your data, right? Rather than going in for a normal pie chart, you can just try this out. Okay, and then we have heat maps, right? Now let's see what is a heat map all about, and I'll let you know how to create a calendar, how to visualize a calendar right here in our worksheet. Okay. Now basically heat map is a visualization where marks on your chart are represented as colors, right? So as the marks heat up due to the higher values or density of records, a more intense color is displayed, right? I'll just show you. Let's say we have our month of order date. Okay, we have discrete months, and let's say we have our subcategory. So now when both are dimensions, we get a text table by default. Okay, you can just bring in sales in color. Okay, and we'll also have sales in size. Okay, and then we have the mark as circle. Okay, now so you can also increase the size of the circles a little bit, right? So now as the value of sales increases, the intensity of the color in your chart also increases, right? So darker the color, darker the value of sales. Okay, so this is why we call it as a heat map, right? Your marks heat up due to the higher values of whatever your measure is, right? And when it comes to a heat map, you can also decide the color using one measure and decide the size using another measure, right? Let me decide the size by profit, right? So though phones is darker in color, the size is lesser when compared to copiers, right? Which means the size is decided by, the size of the circle is decided by the corresponding profit, and the color, the intensity of the color is decided by the sales, right? So in this heat map, we are making use of two measures. One measure decides the color, and one measure decides the size of the circle that we have in our heat map, right? Now let's see how to create a calendar. Okay, so we'll be making use of this heat map to create a calendar, and for that we need to create a few calculated fields, right? As I told you, we'll be creating, and this will also help you go through, help you understand of what different calculations can be used, right? So this is just for a practice purpose. So let's try creating a calendar. Let's try visualizing a calendar right here in our worksheet. Okay, and for that we'll be making use of a few calculated fields, right? So my first calculated field, in order to create a calendar, we need the week days, we need the week numbers, we need the day numbers, and the month names, and also to which particular year that particular month belongs to, right? So we have quite a lot of things that needs to put up into our, that we need to calculate and fetch out from the data that we have in order to create and visualize a calendar, right? So first, let me fetch the weekday names, okay, which means the weekday names as in Sunday, Monday, and so on, in order to visualize, bring in my calendar. So I'll just call this calculated field as weekday, and I'm going to make use of the date name function, okay? And you have the syntax, and you have the explanation, and you have an example for it, right? So the date part that we are going to fetch is the weekday, okay? And we are going to fetch the weekday names from the field called order date, right? So this is our first calculated field, okay? I hope it was quite simple. Just click on apply and okay. So we have our weekday. Next, we need the week number, for which we are creating another calculated field. Now week number, so in Here we have around 53 weeks, right? So in order to clearly display which particular week we are visualizing in our worksheet, we need this week number, okay? And again, we are going to make use of the date name function. We are going to fetch out the week from the order date. Now, when I complete the visualization, you'll clearly be able to understand what is the purpose of every calculated field. We'll also go back to every calculated field and we will try going through it again once we complete the visualization, right? And next, we need to fetch the year to which your the month in your calendar belongs to, right? That is why we are creating a calculated field for year, and we have inbuilt function called year, which simply fetches and displays the year of whatever field that you specify in its inside the year function, right? Just click on apply and okay. So we have our year, we have our week number, and we have our week day. Then we need the name of the different months. Okay, I'll call this as month name. And we are again making use of the date name function. This time we are going to fetch the month part from the order date, right? Click on apply and okay. And finally, we need the different days of our month, right? So that is why we are creating another calculated field called day. We will make use of the date part function. Okay, we are going to fetch the day part from my order date, right? Just click on apply and okay. So now we have our year and day which has been brought under measures. I'll just place it under dimension, okay, because I need discrete values of this calculation, right? So now next we have our year, we have our month, we have the weekdays, week numbers, and the different days of every month, right? Next step is to visualize a calendar using all these calculated fields, right? So first of all, we'll bring our weekdays, place it into columns. So we have all the weekday names right here, okay? And then we have the week numbers that I'm placing into rows, right? So we have around 53 weeks, okay? And then we need to filter out year and month because I need only one particular month of one particular year calendar to be displayed in my worksheet, right? So that, I mean, for that purpose, I'm just showing the filter for month name as well as showing the filter for year, okay? And we will be changing this into a single value drop down, okay? And this also as a single value drop down. You can also have it as a single value list. Just to save the space, I'm going in for a single value drop down, right? In this manner, we are just visualizing only the month of January, which belongs to the year of 2015, right? So this is why we basically made use of our filters, okay? Right. Next, so this is the first week number. When you simply change it into, I would like to say 2017, the month of August, right? So the week number changes accordingly, right? So as a next step, we will bring our day into the text part, okay, where we have the different days and we do have a few blanks, missing dates in between. And as I told you, this is because the data set that we have been provided with does not contain information regarding this particular date. For example, August 10th of 2017, there was no entry made. There's no entry, there's no data available in our data set for this particular date. That is why it has been left blank, right? So as a Tableau developer, we are just visualizing whatever data has been provided to us, right? So these missing values, it doesn't matter. It is again purely based on your data, right? So we are not concerned about that. We are just trying to visualize with whatever data that we have been connected with Tableau, right? So we have our calendar for every month of any year as per your requirement, okay? And then you can just try to color them out. Let's bring weekday into the color marks card where you have a separate color for every weekday, okay? And you can also change the mark to square, right? After which you have a square right next to every day number. And under the label marks card, you have an option called alignment. I'll change it into center aligned so that they are placed right in center of my box of my square. Okay. And next, you can just increase the size of your square. Let me just, yes, you can increase the size of your square. And then you can change the font color to black. You can make it bold, right? So all these colors are purely depending on your requirement. Okay, however you would like to visualize it, you can just go in for that, right? And you can increase or decrease the size. You can edit the label, your size, your font, your color, okay? And you can also edit colors, okay? You can change the colors as per your requirement, right? So this is how you display a calendar, okay? You bring a calendar right here into your worksheet, okay? You can just say, I would like to view the calendar for the year 2016 and the month of December, right? So you have a perfect calendar that has been visualized, that has been brought right here in your worksheet with just a few simple calculated fields that we created. One to fetch the weekdays, the weekday names, to fetch the week numbers, right? The year to which it belongs to, the month to which this particular calendar belongs to, and finally the days that we have simply placed into the text part, right? So after which we have just enhanced our visualization, okay? And as I told you, you can also have it as a single value list, okay? With such radio buttons, you can simply try using this as well. Okay, and when you go in for all, you have all the different months of all the different years that has been brought into visualization, right? So this is just a calendar that we have created and using a few calculated fields, Tableau, right? So this was about creating a calendar with Tableau, right? So what's the real-time scenario for calendar, right? So you might want to have one sheet which is exclusively meant for calendar. So when you go in for dashboards, when you have multiple sheets, you can have a parameter, right, where you're allowing the user to simply choose a year, or you can have such interactive filters, right, where the user will choose a particular year and month whose corresponding data is displayed. And you can also have one sheet which displays this calendar so that the user can easily identify which, what are the missing dates and, anything regarding the calendar of that particular month, right? So this is just for your convenience. Again, if you would like to include this in your dashboard for additional information, then you can just go ahead with that, right? So this was basically just how to visualize your calendar and real-time scenario in the sense, again, as I told you, it totally depends on your whatever data you're trying to visualize and whatever is your real-time scenario. If you are in need of it, if you would like to given a calendar, given a worksheet for a calendar as such, you can just go ahead with that, right? So yes, and the difference between a heat map and a tree map. Now, heat map, as I told you, it the the colors, your map, your chart itself, the colors in your chart gets the intensity depending upon the value of your measure, right? Whereas when it comes to a tree map, it occupies the entire space in your worksheet. You have the structure, which is decided by the dimension, and the size of your structure, the size of your box, your square or rectangle, the size is decided by the measure, right? So both are completely different. They are not the same, right? So these are just different ways by which you can visualize your data, right? So whichever type of chart you feel is appropriate for visualizing the data or analysis that you have made, you can just go ahead with that. We also have something called waterfall chart, and we have, I think, some 2 or more 3 types of charts that can be discussed about. We have something called as a motion chart, right? So we'll just look into that. And when it comes to real-time scenario, it is all up to you to decide which chart will be appropriate, okay, in order to visualize your analysis, your data that you have made with the data that you have been connected with Tableau, right? So I'm just telling you, these are the different options that you can make use of, right? And it is all up to you to decide which will be appropriate for your requirement and for your analysis of your data, right? So I hope you're able to get what I'm trying to say, all right? Waterfall chart, it is just effective for dashboards, right? And for displaying the effect of positive and negative values, right? Now let's say, for example, how sales or profit goes from one place to another, like a waterfall, right? So that is why we call it as a waterfall chart. And let's say, for example, we have subcategories and we have the corresponding sales, right? And in our marks shelf, I'm going to make use of the Gantt bar, okay? And then sort it out in descending order. And we will just make use of this measure in the size as well as in the colors marks card, right? So this just resembles a waterfall, just tells of how your sales moves from one subcategory to another, okay? And this is just another way by which you can visualize your data, right? And we also have funnel charts, okay, that you can create using Tableau. Now these are a few types that is not readily available under Show Me, okay. Under funnel chart, we have a basic funnel chart and we have something called as an advanced funnel chart, right? So with funnel chart, you can just represent, let's say, your measure at different stages or sectors, right? Now let's see how to create a basic funnel chart. I'll have my sales, okay, and I'm going to make use of this segment in the size marks card, okay, and then I'm going to make use of the segment in my colors marks card. I'm just coloring out the entire value of sales depending upon these 3 segments in my dimension, okay, and size is going to be decided by the measure, okay, and I'll just make it into an entire view. And here we have our basic funnel chart, right? And you can simply label them. Let's have the different segments, their corresponding sales. And here in this sum of sales, you can apply a quick table calculation of percent of total, right? So with this type of a visualization, the audience will clearly be able to understand, right, the sales value of which segment is higher, is more when compared to the other segments, and what is the contribution of this particular segment to the total value of sales in terms of percentage, right? So this is how you go in for a basic funnel chart. So first I had my sales in the view, then I just colored it out using any of my dimension, okay, and then I brought in the measure to decide the size of every segment, right? And then we have our funnel chart. You can just make use of any measure, any dimension, and go ahead and create such a funnel chart, okay? And let's see what is the advanced funnel chart all about. Now for this, let's make use of the ship mode. I have the different ship modes, and let's have the corresponding sales, right? And in my marks card, I'm going to go in for my area. I'll just swap this up and I'll have it as an entire view, okay? We'll sort it out in descending order. So now this is the different ship modes and their corresponding sales value that has been plotted out in our graph. right? And it is an area mark card that we have used. Okay, now this resembles half of our funnel, right? This just looks like half of our funnel. Now, just for visualization purpose, just to bring in the image of an entire funnel in our worksheet, we are going to make use of a simple calculated field, right? Now, this is displaying the positive of sales, the positive sales values, right? Now, when I create a simple calculated field, I'll just say negative of sales, right? Just click on apply and OK. Bring this calculation, place it right before the actual sum of sales. And then you have the mirror image, the symmetric part, the left side of our funnel that has been brought into visualization, right? So now this looks like a complete funnel. As I told you, this negative of sales, the calculated field that we have created, is just for visualization purpose. Okay, just to complete the image of a funnel, we are making use of this calculated field, right? Now, when it comes to enhancing the visualization, I'll go into the sum of calculation, which is nothing but this left part of my funnel. I can change the color of it, okay? And I'll label it using the different ship modes, okay?
Just a quick info, guys. Intellipaat provides Tableau online training and certification course mentored by industry experts, the course link of which is given in the description below. Now, let's continue with the session. Just a quick info, guys. Test your knowledge of Tableau by answering this question. What are the components of a dashboard? A. Horizontal. B. Vertical. C. Image extract. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
My requirement, right? So this is how you create an advanced funnel chart, okay? And this mirror image or the left part of our funnel chart has been created using the negative value of whatever measure with which the right side funnel has been plotted out, okay? And this is just to complete the image of a funnel. Just for visualization purpose, we have created this calculation, right? So this was all about an advanced funnel chart. And finally, we look into what is a motion chart, right? Now, as the name tells you, your chart appears as if it is in motion, right? So that is why it is moving. That is why we call it as a motion chart. And we've already gone through the filter shelf, and we are, going through the marks shelf then and there. We are making use of the different marks cards. We've also gone through what is a column shelf and a row shelf. Now we have this page shelf, right? So we'll be making use of this page shelf to create motion charts, okay? And let me say, for example, if I'm using region and if I'm placing it in my page shelf, okay, there's a separate page that gets created for every member of my dimension called region, right? So under region, I have 4 different: central, east, south, and west, right? So when I make use of these options, I have a separate page that has been created for every single region, right? When you make use of these arrows, we have this page is for central, this is for south, and finally we have a page for west. So every member, every value of this dimension will have a separate page that gets created, okay? And let's say, for example, I'm bringing in my order date, okay? And then I'm bringing in the order date in terms of, let's say, month, okay? And the corresponding sales, okay? Now, if I make use of these arrows, you have a separate line graph that is plotted for every year, right? So you have this dimension called order date that has been placed into a page shelf. It has 4 different values: 2015, 2016, 17, and 18. So every year has been allotted a separate page, okay, that you can go through using these options, right? So we'll just go back to our first page, which is 2015, right? You can toggle between these pages using this drop down arrow, or you can make use of these arrow marks right next to them, or this slider with which you can just toggle between these years, right? And you have this option called playback, play, and you have stop option. And you also have one horizontal bar, two horizontal bar, and three horizontal bars. Now this is the speed in which your chart will move, okay? Your pages will move one after the other. And this is the slowest of all, this is the normal speed, this is the fastest of all, right? Now when I go in for the slowest speed, okay, when I click on this play option, you just have to make a note over here. We had our 2015, next comes the 2016, then comes 2017, and then comes 2018, right? So once you click on this play button, automatically the pages start appearing one after the other, okay, depending on whatever speed you have wanted your pages to move in, right? If I go in for a normal speed, when I click on play option, now this is a little faster. Okay, now this is how your different years, whatever data is present, whatever chart is present for every year of this particular dimension will be appeared as if your chart is in motion, right? And you can also look into the fastest of all. This is going to be too quick, right? You can just make a look, you can just note this part over here, which tells you which year this particular page or line graph corresponds to, right? Now, when I click on play button, you just have to make a note on this year. Now I'll click on play, and as I told you, it was too quick, right? Of how the line moves from one year to another, right? Your pages are moved, your pages appear one after the other, okay, of whichever dimension you have placed in your page shelf, right? Now you can also go in for a continuous month, right? When you go in for a continuous month, let's say I'll go in for a normal speed, and here you have the line graph for the first year, second year, third year, and the final year. This is how your chart moves, right? So depending upon whether it is a discrete date field or a continuous date field, you can move, you can display this motion chart, okay? And this option called show history, right? Now, when you click on play button, we have quite a lot of options on show history, right? For example, let's say I would like to highlight, I would like to show the history for all the marks, okay? And you can just format the amount of fade or the formatting color, okay? And now when I click, now as you notice, you have a faded history, a faded line chart for the past years, for the history, right? So we have shown history with a particular amount of fade, okay, for the previous years. So which means when I click on play option, we have the first year, second year, third year, and the final year with the history, with the past years whose line graphs is faded in nature, right? So this was about how to show the history. And when it comes to marks, trails, or both, this is right now unavailable, right? Only when you choose the circle mark from your marks card, you will be able to select trails or both, right? If I say show only marks, when I click on play button, only the plots will be highlighted in history, okay? If I say show trails, right, this is how it appears, okay, as of from where the start, how the starting of this, and you know what is the trail between, you know, between these different line graphs of these different years, right? Now if I say show both, okay, and you can decide your, again, your color, your trail format, whether it should be a dotted line with this thickness or this color. These are the formatting options. Now when I click on play button, right, now this is how it appears, right? So you are just showing your history, okay? You can also show it only for the last, let's say, 2 months, right? And you can show marks, you can have separate color. Okay, so it is all up to you, right? So for only for the previous 2 years, you are displaying your history, right? So yeah, so basically your chart appears to be in motion, and that is why we call this as a motion chart. Okay, so any dimension that you place in your page shelf will, every member of that particular dimension will be allotted a separate page. As we also went through region, you can also have categories, right? So for every category, you will have a separate page that gets created, and you can create any bar chart or any type of chart over here in the worksheet, in the workspace, which will be available only for this type of category. And you can make use of these play options, the speed options. You can also customize. When you click on this drop down arrow right next to your title called category, you can either remove the title, you can edit your title, whatever it is supposed to be, you can customize it, which means you can, for example, remove the slider, okay, or you can also remove the playback controls, you can remove history controls, you can also remove the page readout, or you can bring them back, bring the slider back, right? So these are a few options that you can customize of how your page shelf option, your page, your motion chart options should appear in your worksheet, right? So this was about a motion chart. It appears as if your chart is in movement, is in motion, right? And that is why we call it as a motion chart. Okay, so we have just gone through all the different types of charts and graphs that can be created with Tableau. Okay.
And this quickly brings us to the roles and responsibilities of a Tableau developer. There are lots of roles basically when it comes to Tableau, and the most important thing that you need to know is that it is basically well suited to the people who really like problem solving skills. They want to be a team player, and they know how to manage their time very effectively, and this is done to ensure that they all meet their timelines and keep to the projected schedules as well, guys. So there are more than 5 roles which Tableau developer can assume, but the 3 main ones which the companies are hiring for on a constant always are Tableau developer, analytics engineer, and a business intelligence architect, guys. So you can be called as a Tableau developer, an analytics engineer, or a business intelligence architect if you are a certified Tableau expert, and if you pretty much have good experience working on with Tableau, or that you want to learn, and after learning, mastering the concepts and having a certificate, you can pretty much exploit all of these designation, guys. So coming to responsibilities, the most important responsibility in my opinion is the first point, because again, you need to develop, you need to maintain, and you need to manage advanced reporting, guys. It's not just basic XY axis and put some graphs. You just saw what the analytics looks like. So you need to manage advanced reporting, you need to do very good dashboarding, and you need to provide other business intelligence solutions at the same time. And then you need to be performing very good data analysis, you need to document whatever you're doing, you need to provide validation to the data that's being processed, and you need to know how you can design and map these data and convert it from raw data into good information as well. And the third point is pretty much you need to be on the roll, you need to be a runner when it comes to this, because you need to review and improve all their existing systems. You need to collaborate with brand new teams, brand new people, lots of teams, to basically integrate all of these new systems in case they're using any legacy or old applications, guys. And then after this, you need to conduct a lot of tests, because again, unit testing is something very important when it comes to Tableau. And then you'll be developing very good amount of database queries, because you need to know how these affect your visualizations, right? So basically, you'll analyze whatever the effects that your dashboarding brings about, and then if there are any issues with that, you can troubleshoot the same, fix it, test it again, and do all this again. So the last point is again creating amazing tools to store data within the organization, because again everything from storing data, managing data, analyzing data, and putting out dashboards, you as a Tableau developer will be responsible for all of these, guys. And this quickly brings us to the skills of a Tableau developer. There are 3 major skills of a Tableau developer that are considered very important: programming skills, statistical skills, and data handling, guys. And I'm sorry. Coming to programming skills again, having very good statistical programming languages and having knowledge in them, like Python and R is a very good skill. And at the same time, knowing a statistical language is not as important when it comes to if you cannot make it talk to data. So having a good database querying language and knowing something like SQL is a great start as well. And having very good mathematical skills, very good understanding of statistics is a must. And being familiar with mathematical testing, statistical testing, distribution testing, maximum likelihood estimators is also a requirement, guys. And this basically will help you achieve better analytics. And guys, do not be overwhelmed by the skills that you need to become a Tableau developer. Again, you will be trained on all of these, and after being trained, all of these will look very simple to you, because at the end of the day, if you're training with a good certification program, it will make you an expert in all of the skills that's being shown on your screen right now. And then coming to data handling, again, you need to understand the data you're working with. You need to wrangle through the data and see how it works, because if the data can be exploited in a good way, it can pretty much give you great analytics, and you can drive all of your models, whatever business requirements you have, through a success, guys. And after this, again, as I've been telling, data is very unruly, data is raw, and it needs to be refined all the time. And making sure that you're using the refined data to give visualizations are very important as well. And knowing data management techniques are very good, and they form a very vital requirement as well, guys. And this brings us to the average salary of a Tableau developer. I've broken it down into two terms in the United States of America and in the subcontinent of India, guys. So a junior Tableau developer in the USA gets somewhere around $75,500 annually, and in India gets a junior Tableau developer gets somewhere around 7 lakhs per annum. And then coming to a senior Tableau developer with some amount of experience, very good certification and great knowledge, gets a package of somewhere around $105,000 in America and 17 lakhs per annum in India, guys. So these are average numbers, and there is no hard and fast rule that you will get these numbers. Again, you can get 15 lakhs per annum for a junior developer, 25 lakhs per annum for a senior developer as well, guys. It all depends on your skill. It all depends on how good you are, because companies these days don't mind paying a lot if they know you are good at what you do and you bring a lot to the table, guys. Irrespective of where you are, irrespective of what money you ask for, if you're damn good at your job and if you are certified, and people know you're hiring, people know that you have put in some work to understand the data and you can drive their business to success, they are ready to pay lots more amount, guys. So this quickly brings me to the learning path of a Tableau developer. Well, the most simple way that you need to go about learning Tableau is, again, first you need to understand the basic W's of data analysis, guys. Why, what, when, who, and so much more. All the questions which start with W will be your first starting point of data analysis. And after that, you will be learning the basics of mathematics and statistics. And after this, you'll be learning all the data blending techniques, where you'll be understanding data, churning through data, and figuring it out. And after all of these, you'll be working with data hands-on by learning a couple of database technologies, querying, SQL, and so much more. And after that, finally, you'll be using all of the 4 skills you've learned previously, all the routes that you've taken to come there, to visualize all these data, to create reports, dashboards, and to go on to become a certified and pretty much a very good Tableau developer as well, guys.
Now, moving on to what exactly is Power BI. So it is a business analytics tool which was developed by Microsoft in 2013. It is generally used for interactive data visualizations and business intelligence. It provides an interface which is easy and simple to understand and work with. End users can create their own dashboards and reports using Power BI. Right. Now, as we've discussed about these tools in a brief, now let us discuss about the data visualization in both of them. Right. So first and foremost, let us understand what exactly is data visualization, guys. So data visualization is nothing but representing the particular data in the forms of charts, diagrams, graphs, and so on. Instead of going through the reports which are made up of complex and large amount of data, you can just use graphs, diagrams, charts, etc. That is, as they will be more convenient for the users to understand, isn't it? Which BI tool you should choose for data visualization? Well, it depends. If you're looking for a data visualization tool for customized data visualization, then you can go with Power BI, as you can drag and drop into the visualization through a sidebar and you can import the data as well. right? It also has opened up software development kit, which helps to convert data from various data sources into interactive reports and dashboards. Whereas when it comes to data visualizations using Tableau, then it is majorly used for pure visualization. Like if you're looking for a more organized and clean approach, then you can choose Tableau. In this, data visualizations are created in the form of worksheets or dashboards. Right. Tableau provides connections to multiple different sets of data sources, and it is majorly used for larger sets of data visualization in an organization. So it has additional drill down features also. Now let's move forward and discuss about few of the parameters based on which we will differentiate between both of these tools. So the first parameter that we have is performance here. So guys, in Tableau it can handle large amount of data from different data sources with better performance, whereas Power BI can only handle a limited amount of data here. Second parameter is the source of data. Power BI has limited access to the other servers and databases as compared to Tableau. For example, Oracle databases, PostgreSQL database, SQL Server database, SAP HANA database, and so on. Whereas in case of Tableau, it has got access to multiple number of different servers and database sources such as text file, JSON file, PDF file, Excel, statistical files, Microsoft SQL Server, MySQL, and Oracle, Redshift, and the list goes on. Right. Now, in the third point we have is the difficulty level of learning or learning curve. So guys, in Power BI, it is comparatively easier to learn as compared to Tableau. Even if we see from the learner's point of perspective or the business point of perspective, Power BI is comparatively easy to understand as well as easy to learn. I'm not saying that Tableau is very much difficult to learn or understand, but Power BI is comparatively a little more precise when it comes to such kind of terminologies, right? So now if we talk about its data capability, so guys, in Power BI, each group or workspace can handle up to 10 GB of data, and more than 10 GB of data are supposed to be in cloud or Azure, I would say, right? But if it is in local database, then Power BI just pulls the data and does not import them. But in case of Tableau, it works on columnar based structure, that is, it only allows to store unique values for every column, and that is how it is possible to fetch billions of records or rows in this. Right. Now moving towards our fifth parameter, which is integration. So with integration, in case of Power BI, you can easily integrate with different data sources like SharePoint, Azure, Power Flow, Power Apps, 365, Excel, and many other Microsoft products. Whereas Tableau is used for more scalable approach here with different outsourcing tools as well, even including all of these Microsoft based tools as well as outsource based tools also, right? And the sixth parameter is about the data shaping. So guys, Power BI offers query editor which allows its users to do many things in an easier manner, and it is more flexible. It also offers self-documenting and other features as well, whereas Tableau does not offer any of these kinds of services. Now the seventh parameter that we have is the data modeling. Power BI provides Power Pivot, DAX, which are more accessible to the users, whereas Tableau does not provide any of them. Finally, we have application. So guys, Power BI is used for dashboards, custom visuals, and more like open source approaches. But Tableau is used for longer run operations and ad hoc analysis. As we have discussed about the parameters, now let us head towards the pricing part. So guys, when it comes to pricing, then Power BI is more affordable option as compared to Tableau, because Power BI offers 3 subscription tiers, that is Desktop, Pro, and Premium. Desktop cost is not chargeable for its users, and Pro cost starts as $9.99 per user per month. Pro also offers 60 days of free trial, and in this, server cost, web user cost, etc. is lesser. And the premium plan starts at $4,995 per user per month as per the storage resource.
Just a quick info, guys. Intellipaat provides Tableau online training and certification course mentored by industry experts. The course link of which is given in the description below. Now, let's continue with the session.
$35 per user per month, and Tableau viewer cost starts at $12 per user per month, which is a bit higher as compared to Power BI. So if you look at it from the initial cost perspective, then Power BI is way cheaper as compared to Tableau. But for longer run, that is total usage cost per year is lesser in Tableau. So guys, after knowing about pricing, let us differentiate them based on some of the functionalities of both Tableau and Power BI. First, we have in the functionalities is the support level. So as in Power BI, customer support is limited for users for free BI account, and it offers robust support resources and documentation, whereas Tableau offers comprehensive knowledge-based support for its users. Now, if we talk about licensing, then Power BI has rigid licensing, whereas Tableau has flexible licensing. And in case of infrastructure, Power BI has SaaS or software as a service infrastructure, whereas Tableau has a flexible infrastructure here. And when it comes to scalability, for larger data set, Power BI has good scalability, whereas Tableau has much better scalability for larger data sets as compared to Power BI.
So, coming to the first question on the top Tableau interview question set, the first question usually goes with a comparison question because it is vital that you understand the differences. For example, the question states, compare ClickView with Tableau. I'm sure you already know that both of these are amazing business intelligence tools that you can work with very easily, and each of them have their own niche applications, right? So let's check out the differences. So whenever we talk about data integrations in terms of capability with Tableau and QuickView, Tableau has an edge over QuickView in this particular sense. And then whenever you're working with multidimensional data as well, Tableau has the capability to handle it that much better, efficiently and faster. And of course, most of us work with PowerPoints as well, so whenever you have a lot of work with PowerPoints, dashboarding on that and creating good amount of visualizations and insights on that is great, especially if you have the support for PowerPoint, right, the native support, and Tableau does that, while ClickView is a little bit held back in this regard. And then when we talk about scalability and visual drill down as well, right, in terms of visual drill down, yes, ClickView is amazing to work with and it provides good amount of efficiency, so you don't have to do a lot to have a big impact on the output. But then when you talk about scalability, right, scalability, Tableau, there is no beating Tableau out here, because ClickView has a direct limitation applied because of the ability of it to maximize its usage of RAM, while with respect to Tableau, right, so it can scale and RAM is not a limiting factor out here. So this is the basic comparison that you can state to the interviewer whenever you ask the comparison between ClickView and Tableau. And now, when we come to the second question, it states, how is the context filter different from all of the other filters? So one thing you always have to know is that whenever you create a context filter, right, what Tableau does for you is that Tableau will create a temporary table just for this particular filter. So when you create a context filter, Tableau will create one temporary table just for this particular filter set, and every other filter will get applied on the context filter, guys. So every other filter will get applied on the context filter as if it was cascading parameters, right? Pretty simple and straightforward. But then when you have created an actual context filter, let's say on an example such as countries, USA and India, what Tableau will do is Tableau will create a temporary table for both of these countries and all the data that goes into these particular countries as well. And let's say now if you have any other filters that have to be applied, and if you do not have any context filter, right, and every single record will actually be checked for filters and then applied if required. So if you have a context filter, make sure to mention about Tableau being able to create the temporary table and then mapping the data based on it, and later applying all of the context filter data on top of it. Now, moving on to question 3. Question 3 is again another follow-up question. It's regarding context filters itself. So the interviewer may ask, what is the disadvantage of making use of context filters? Well, the context filter is an entity that is actually not changed a lot around by the user, right? So what happens is, if you have to change these context filters, then in the backend the database has to be reamped, it has to be recomputed entirely, and whatever temporary table has been created during your first set of filters will be removed. It'll have to be rewritten, and all of these takes a lot of time, effort, and computation power as well. So at the end of the day, it's all about slowing down performance if you have to change your context filter. And then, whenever we are adding dimensions to context, right, what Tableau does, we already know this, is that it creates a temporary table. And one disadvantage with creating a temporary table is that every time we initiate a view, or every time we instantiate a view option, or check the output, so what usually happens with this is that since it's creating this temporary table, it will reload it every time. So creation of a temporary table leads to a lot of reloads as well.
And one more important thing you have to know is that whenever we're working with tools like Microsoft Excel and Access, or let's say any other general, text data sources, right? So the temporary table that gets created actually gets created in the Microsoft Access table format. This can be a disadvantage if you cannot scale this into other tools in case if you have any down the pipeline as well. And then of course, whenever you're working with SQL Server, let's say Oracle data sources or even MySQL, you must have the explicit permission to create that temporary table on the server itself. So having these access parameters and having these permissions is very vital too. So the talk is not always about a single dimensional data, right? So whenever we talk about multi-dimensional data sources, temporary tables usually are not created for this, and context filters are basically defined through which an understanding on what filters are independent, what filters are dependent, and then later mapped and put into place. So since temporary tables here are not being created, and since you're basing it on the fact that it is either independent or non-independent, this might again take a little bit of hit as well. So these form to be some of the disadvantages of making use of context filters. Now, question number 3 states, what are the 5 main products that are offered by Tableau? Well, this is something you really should know as a person interviewing for a Tableau developer interview or any of the similar roles. So make sure to mention all 5 of these products. We have Tableau Desktop, we have Tableau Server, we have Tableau Online, we have Tableau Reader, and we have Tableau Public. With this, we can check out the next question, the 5th question, that says, what is the latest version of Tableau Desktop? Now, this is a very tricky question, and it's asked in a lot of Tableau interviews is what we've seen. And this is only done to make sure that you are up to date with the latest version of the tool, that you understand all of the change logs of what Tableau is changing around, right? See, Tableau, after it came out, it has had a huge number of changes. It's become very efficient now. It's become very beautiful, very easy to use, and all of that. Alongside this, there have been a lot of changes as well. So what the interviewer expects with this question is to check if you are up to date on their website, to check out all of their latest offerings to make the full use out of it for your business intelligence solution as well. So as of September 2020, when we're recording this particular video, their latest version of Tableau Desktop is version 2020.3. That's March 2020. Well, moving on to the 6th question, it says, what is data visualization? Now guys, data visualization, business intelligence, all of these are key questions that are asked in Tableau interviews, so make sure to pay attention, right? So whenever you speak about data visualization, you can talk about what it is, right? So what we usually do is we have data either in a structured or an unstructured format. It can be in a presentation, it can be in an Excel sheet, or it might come from a variety of different sources. So instead of looking at an Excel sheet which has probably 100,000 entries, we create beautiful looking dashboards through which we can gain some insight, which would have been very difficult to do with the naked eye unless we had this visualization, right? So that's the basic aspect of data visualization. You can have multiple graphics, you can have complex looking animations, and you can have aesthetically very pleasing to look at graphs as well. So this will help, especially whenever you have to pitch a product to a person who is not from a technical background, or let's say if you have to explain a concept to your juniors, or even in a business meeting where a lot of graphs will make more sense rather than an Excel sheet with 100,000 entries, right? So you can use an approach like this to answer this question. Now, moving on to the 7th question, it states, why Tableau? So the interviewer here is again trying to find out why and what is your inclination with making use of Tableau and where it shines. So you can talk about all of the advantages of Tableau, and 2 of the most important concepts that you have to talk about is about data sharing and how you can analyze it, and later it's about creating views and the ability to share it. Let's walk over with the first one. So let's say you have data from multiple sources, right? You might have a server on premise as well. You might have a database in that server, or let's say a database on the cloud, a data warehousing solution, a cloud application, or an Excel file, or a PPT file, whatever it is. With Tableau, you can analyze this very, very easily without having to put much effort. This is point number 1. And then point number 2 you can state is that, so it doesn't end with you creating beautiful looking visuals, dashboards and all of that. At the end of the day, you have to have the ability to easily share it across your team, across the floor, to make sure that people in your team and people from a variety of other teams can access to this, right? So you can have the sales team look at the data, you can have your data analytics team understand the data, you can have your data engineering team in fact come look at the data as well. So your ability to easily share this data, blend it and merge it with other data, and one important thing is to keep it up to date automatically, right? So all of these can be done very easily with the help of Tableau, guys.
Just a quick info, guys. Test your knowledge of Tableau by answering this question. What are the components of a dashboard? A. Horizontal. B. Vertical. C. Image extract. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So with this, we can check out the 8th question that states, what are filters and how many types of filters are there in Tableau? A filter, as the name suggests, is used to funnel data. So what are we funneling out here? So let's say we have 10 rows of data in an Excel sheet and we only want to see the data from one particular person, or let's say of one particular criteria. Let's say if you have the student details of a particular college, we want to filter them by name. You usually filter them by age. Let's say you want to pick up all the people, all the students in the college of the age 23 years. So applying a filter will make sure that the backend will run and it will only show you results of these students who are of age 23, right? So we're trying to prevent unnecessary data in that context, and we're trying to only see what it is that we exactly require and then work with that. So for this follow-up question which states how many types of filters are there are 3 types of filters and we already checked out one, right? So there's quick filters, there's context filters, and there's data source filters. So make sure to mention all of these when this question is asked. Now, moving on to question number 9, it says how to remove the show all option from a Tableau auto filter. See, again, this is a question that is asked to see your proficiency in terms of handling the tool, even though you might not be sitting in front of the tool right now, right? So when you think about it, answer this question in a very simple way, in a very straightforward way. It's a very straightforward question with a very simple answer. So to remove the show all option, right? So all you have to do is right click on the filter, click on the customize button, and it's a simple uncheck on the show all button, and this ensures that the option is actually, and this ensures that and then after you uncheck all of this, right, this makes sure that your option is removed. So since you're sitting in front of the interview, even though you might have a laptop, that's it is an added bonus that you first verbally say out the answer, and then of course you can run Tableau Desktop on your machine right then and there, and then show all of these practically to the interviewer as well. So make sure to keep that in mind. So moving on to the 10th question, it states, can we use non-used columns, as in the columns that are not used in the reports but that are present and used in the data sources in actual Tableau filter? So can we use non-used columns in Tableau filters? The answer is a very straightforward yes, right? So think about an example when you're approaching with this. So if you have a data source where you have employee data, right? So you can have employee ID, employee name, the department, designation, salary, and all of it. And let's say now we have reports where we're only using employee name and employee salary, right? So what you can actually do is you can apply filters on employee designation even though you have not used these reports from the data source, right? So it is very simple, it is very straightforward, and yes, it is achievable. We can make use of non-used columns, but then it has to be used in the data source, but then it really doesn't have to be used in the reports, guys. So moving on to the 11th question, it states, what is the benefit of Tableau extract file over the live connection? Well, when you think about Tableau extract file, right? So extract can be used anywhere without having to create a connection. That's the biggest advantage of it. So you can create your own custom visualizations without even having to connect to a database prior as well. So this is the ability provided by the Tableau extract file, where you can pull in all the data and work with it without even having to connect with that particular database as well. Now with this, moving on to the 12th question, it states, what is the difference between TWB and TWBX file extensions? Please explain. Well, one thing you have to understand is that whenever we talk about TWB, right, the Tableau workbook files, it is that it is a live connection. It points directly to the data source, and whenever the user is receiving a TWB file, he or she needs permission to access the data source. And with a TWB data file, no data is included prior as well. So it's a live connection. It points to the data source, and you need permission to access the data source. And initially, there is no data that comes included with the file as well. Now, whenever you talk about TWBX file extensions, right, here what we're actually trying to do is we take the data offline and we store it on the local machine. So be it in a package, be it in a zip file or any other packaging files, where we completely remove this kind of dependency of having to need the permissions and having to have these access protocols in case if you do not have all of that as well. So TWB files require permissions from the data source, but then TWBX is all about bringing the data offline, keeping it in the native place, and to make sure that you avoid the need for permission as well. Now with this, we can check out the 13th question that says, what is the maximum number of tables we can join in Tableau? So this is a very commonly asked question, and you are supposed to know the answer to this, guys. It's a very straightforward answer. So in Tableau, we can have a maximum of 32 tables that we can join at a time. And no, it is not possible to combine more than 32 tables in a very straightforward way either. So make sure to answer this in a clear and a concise way. Now with this, moving on to the next question, it states, what are dimensions and facts? Again, it's a very simple example, but it always adds a lot of value if you can explain it with an example, right? So dimensions are nothing but the text columns where we are describing what the actual data is pertaining to that column, right? So you can have a product name, you can have the name of a city, and a lot of other things. So dimension is nothing but the simple description of what data we are trying to pull in from that particular column. And then when you talk about facts, right, facts are the actual measures of data that you might have in that particular data set. So whenever you think about facts, think about numerical values, right? So you can have a profit percentage, you can have the profit in, of course, in monetary value, you can have the sales figures, you can have the sales in that particular monetary value as well, and a lot of other things. So when you think about dimensions and facts, it's a pretty simple concept. Now, moving on to the 15th question, it states, can we place an Excel file in a shared location and use it to develop a report and refresh it in regular intervals? What the interviewer is trying to ask is to see if you have had the experience of doing this. So let's say if you had the data source, an Excel file, and if you had to place it in a shared location, could you actually use that right from there directly to create a report and then refresh it as and when you require? The answer to this is yes. Tableau is an amazing tool. It's very powerful to use, and yes, it can be done in a very simple way as well. But then if you have a requirement for better performance, right, it is always vital to extract it, bring it to your machine, use it locally, and then work with it. But then if your criteria doesn't really have to do much with having the best performance possible, then yes, it is possible to work with a shared location file and to develop a report and later update it as and when you require as well. Now, moving to the 16th question, it states, what is the difference between a heat map and a tree map in Tableau? Well, guys, a heat map is one of the things that you really have to know, and I'm sure you guys would have used a tree map or even a heat map for that particular instance in your journey of learning Tableau as well. So a heat map is nothing but a very simple way where you can categorize the data in that particular data set by making use of variety options of, let's say, sizing, or let's say even by making use of a variety of color as well. So why do we do this is to make sure we differentiate it from one entity to the other, right? So you can map and check all of the orange color looking entities on your screen right now. You can try to differentiate and compare all of the black colored entities. So you can try to compare all of the black colored entries to another colored entry as well, right? So using colors and sizes is an amazing way, and it can be done using a heat map. But then now when you're talking about a tree map is far more powerful than a heat map, because here we're trying to have a hierarchy. So here we're trying to have a structure which is very similar to a tree data structure, and here we're trying to So not only are we trying to visualize a part of the relationship here, what we're trying to do actually is in a very simple way denote the entire relationship that exists between entries for our particular workbook as well. So as you can see on your screen, you have the states of United States. So you have all the state names of the United States of America, and you can map it based on color as well. You can map it based on size, and eventually you have a hierarchical tree structure through which you have mapped it, and the node structure goes on and on, very similar to a tree structure. Now moving on to the 17th question, it states, what is balanced access? Well, in a balanced axis, what happens is that there are multiple measures that are actually shown on a single axis, and all of the marks that are shown, right, it's all done in a single pane as well. So to do this, all you have to do is you have to first drag a dimension into a column, and after you have dragged the dimension, all you have to do is drag the first measure and drag the second measure, but this time not to a different axis but then to an existing axis, right? So you can see the simple difference between the second and the third point, and this is what that makes a blended axis what it is. So dragging a dimension, dragging the first measure into the column, and dragging the second measure onto the existing axis rather than a new one. So this is all about blended axis. Now when you think about the 18th question, here is another very fun question which again is asked a lot. So what makes Tableau stand out from all of the other tools, right? So whenever we talk about business intelligence, whenever we talk about all of these tools, they are fantastic to use. I'm sure all of the developers who have went into creating all of these tools have taken a lot of time, pain and effort to make it very easy for us to use, right? So thinking about that, all of the other BI tools are extremely pricey and can get out of hand if you're a small company. But then what Tableau does that's very different from most of the other people is that they have a free offering, right? So Tableau Public is free, and it has an academic distribution in case if you're a college student and you want to learn and work with Tableau as well. So having this option to use it for free definitely is a standout point. And then when you think about how well recognized Tableau is, all of the big firms make use of a business intelligence tool in one way or another, right? Right from the startups to all the trillion-dollar businesses out there. Tableau, in fact, is also well recognized by very big firms such as Forrester Research, and it's considered to be one of the most easy to use product as of now, and one of the most agile products available as well. So it's not only just this, right? See, there are other BI tools which can do a lot of things more, in a substantial way than what Tableau can do. Tableau is just a data visualization tool, but then you can have and do a lot of things. But then you can have a lot of other tools which have a complete technology stack that they bring along as well, right? So considering that, you will have to make use of these other products along with Tableau. Let's say if you have enterprise grade data to perform ETL, maintenance, data storage, and all of that as well. So in that regard, definitely it is one of the vital points to mention of why Tableau stands out the way it does. Moving on to the 19th question, it states, how do we do data testing in Tableau? This is a tricky question, and I've put in a lot of tricky questions for this particular presentation as well. So make sure you pay attention throughout. Now, how can we do data testing in Tableau, right? When you think about it, data testing is not possible in Tableau because Tableau is a data visualization tool and it is not a testing tool such as Selenium or something. So make sure to answer it and do not be confused. The interviewer may be trying to see if you get confused with concepts such as this. So it's a very straightforward no. Tableau is used for data visualization. Tableau cannot perform data testing, but of course it is one of the best tools out there for data visualization today, especially when you have data which is already pre-processed or data which is already structured, and you can work with it easily as well. But still, it doesn't add a lot of value in terms of data testing as well. Now with this, coming to the 20th question, it states, can you get values from two different sources as a single input into our parameter? The answer is no. Tableau currently actually does not support multi-valued parameter, right? So, there's actually a technique which is called as the dynamic parameter with a blend technique that can be used to highlight every single value out there. But then you cannot make use of multiple values because this is how Tableau is built and this is how Tableau is, worked on. And one very important concept that you should know whenever you're answering this question is that the parameters in Tableau, right, they are not dynamic. So you literally cannot start filtering stuff at the runtime as well. So So this is something which you should talk about along with the technique when you ask this particular question. So the answer is no. Currently, Tableau does not support multi-valued parameters, but then of course, down the line with a lot of updates, then it definitely is something that we all are waiting and in anticipation for as well. Now, moving on to the 21st question, it states, how do we use parameters in Tableau? So you can use parameters with the following entities, right? You can use parameters, map them with filters. You have parameters across calculated fields, across actions. You have measure swaps, you have changing views, and you have auto updates as well, right? So make sure to at least mention 3 or 4, but then it really adds value if you can mention 4, 5, or in fact all of these as well. So using parameters in Tableau is definitely a core concept, and you're supposed to know it in and out at this point of time. So it always adds values to talk about where parameters are used and in fact how parameters are used as well. Now, moving to the 22nd question, it states, what is the use of the new custom SQL query in Tableau? Well, one thing you have to know about is that the custom SQL query, right? It's a query that is written after you've connected to the data and you want to pull the data to have a structured view of it. Now, to give you an example, think about having 50 columns in a particular table, but then we do not require 50. We only want 10, 20 or 30 of it. So instead of taking all the 50 columns and then working with it individually, what we can try to do is we can write an SQL query that has the ability to filter out and just give us the 10 columns that we want, and then work with it later and create a structured view based upon that. So why do we even have to do this? One, you want 10 out of 50, you're getting that straightforward. Number 2, when you think about computation power, the performance will go up to an exponential extent, because this is a very simple example that we're talking about. In an actual production environment, this will not be the case. So the performance hit in case when you want 10 but you still have to pull in 50 is avoided. If you want 10 out of 50, you can have 10 out of 50, guys. That's a very simple example. Make sure to state it with the example as well. Now, moving on to the 23rd question, it states, what are the differences between Tableau and other traditional BI tools, right? One thing you already know about Tableau if you're here is that it is one of the most easiest tools to use. It's best in its class. It has a free offering, and in fact it provides very good visual analytics capabilities as well. So whenever you think about data foundation concepts, here is where Tableau has it a little slow. It really doesn't help with plumbing, so you will have to make use of an SQL server alongside Tableau to have the complete package of using it. And of course, Tableau licenses can get relatively expensive if you're looking to scale up your organization and scale up your data quickly as well. But then traditional BI tools can do it all, but then it might have a significant cost upfront, and then with a lot of parameters, right? So think about higher consultations, you have hardware changes, you have to have good software there as well. So all of these will cost money, and this will come up to you as soon as you get started itself. So that is one of the biggest differences. And then when you think about all the big vendors out there, right? So if you have to check about reasonable value for money, and if you have to check about what best you can get for the money that you've spent, someone like Microsoft is the person who can do it to the best of their capabilities, right? So they're a huge organization. And then when you think about open source vendors, there's Jaspersoft, there's Pentaho, and there's a lot of other tools that you can make use of as well. But then this does not have an enough talent pool as of yet. This does not have the enough amount of traction that is required for developers to kick in full time to build Pentaho and Jaspersoft into an amazing tool that can directly compete with Microsoft's offerings as well. So think about Tableau, think about Power BI, think about tools like Pentaho, Jaspersoft, and you will have a clear understanding of where the basic differences lie as well. Now, so moving on to the 24th question, it states, what are the similarities and differences that lie in between a tool like Tableau and a tool like Palantir? Well, one of the things you really have to understand is that Palantir and Tableau do things very, very differently, right? So Palantir is known for its ability to be a security tool in terms of handling problems such as fraud detection, handling the payments and all of that, right? So the customers, or let's say the investors in Palantir, are people such as PayPal, the Central Intelligence Agency, and a lot of others. And on the other end, you already know that Tableau is a visualization player. It has its roots very strong into the Stanford University university research as well, right? So one thing it'll always add value is that you talk about new points, right? So think about VQL or VisQL. So VisQL is basically the visual query language that will allow users to build any sort of visualizations that require on already existing data warehouses and spreadsheets, right? So Tableau's support for this is definitely a point that you can mention whenever you asked to talk about Tableau as well. So here is another point to your arsenal of Tableau knowledge. Moving on to the 25th question, it states how to create cascading filters without making use of a context filter. Well, it's very simple. All you have to do is think about a situation, right? So let's say we have two filters, filter 1 and filter 2. And based on filter 1, we have to make use of filter 2 on that particular data. And now when you have to say, and now let's think of it as filter 1 being country and filter 2 being it as states, right? So if you choose the country as India, then filter 2 must display filter 2 must display only the states of India and not states of every single country out there, right? So this is how you can cascade filters without having to make use of a context filter. Now to do this, right? So for the filter 2, make sure you select the option wherever the value. So make sure you select option of only relevant values for the filter for the second. So make sure you select the option for only relevant values for the second filter, to actually go on to do a thing like this. It's a pretty simple thing and it can be easily done by making use of Tableau. Moving on to the next question, it states, is Tableau good for a strategic acquisition? Well, of course, Tableau is an amazing tool for strategic acquisition as it provides amazing data insights, and you can do a lot more with Tableau with the approach of you having to put in a lot less effort as well, right? So in terms of acquisition, what it does, it will help you plan properly, set up a pipeline, understand what anomalies are lying there, and try to fix them as well. You can improvise your entire process and have it better as well. So it'll give you a lot of insights which might skip your eye if you're directly looking at the data with your naked eye as well. So in terms of strategic acquisition, it's a big yes for sure. Coming to the 27th question, it states how to display the top 5 and the last 5 sales in the same view. So to do this in a very simple way, there are two ways. Make sure to mention both as well. One, of course, you can apply filters where you can do it in a straight way, and number two, you have calculated fields where you can achieve the same effect of, let's say, top 5 sales and the last 5 sales in the same view without you having to do much as well. So make sure to mention the both ways. Now, question number 28 states, let's say, suppose without having to use a line or a bar chart, I want to design a view to show the region-wise profit of sales. How can I go on to do this? So what we're trying to do here is, we want to show the region-wise profit and sales without having to use a line chart. So how would you suggest that we do it? If you do have a computer or a laptop in front of you right now, it will always add a lot of value if you can show all of these practically with any of the previous projects or data sets that you might have worked with. But then take a simple approach to verbally explain it first. See, for example, you can generate a map by making use of cities, and later, you can just drag the profit and all of the sales to that particular details, and then, add the state as a quick filter and work with it as well. So you can use a very simple approach, and to explain it can be done in a very simple and a concise way, but then it'll add value if you can show it practically, right? So pull out a data set, and tell the interviewer that you want to show how this can be done practically as well. So that will impress them definitely. Now, moving on to the 29th question, it states design a view in a map such that if a user selects any state, the profit and the sales in the cities under that state would show up. So if someone selects any state, right, so whatever the profit is there in that particular state and whatever sales in the cities of that state, that should show up. How can this be done? This can be done if you have state, city, sales and profit as our fields in our data, right? So we require these data. Make sure to mention that first. Without the data, you cannot mention it, right? And to have this particular effect, so all you have to do is click on the state field, drag the city out into our marks card, which comes under the state field, of course, and then drag the sales into size, drag the profit and drop into the color, click on the size legend. You can, increase it to whatever size that you require, say for example 75%, and then click on the state field and show quick filter. And after you have done that, all you have to do is you have to select any of the states and see if it is working or not. So if you've done steps from 1 to 6 right, then of course with the 7th step you will have the view which indicates the number of sales, and the color will directly indicate the profit values as well. So it's a simple thing with 6 simple steps. So this is the hardly 30-second task, but then at the end of the day the insight you can drive out of this task is huge. So make sure you mention the advantage, how to do it, and what we require to do it as well. Now moving on to the 30th question, it states how to add custom color in Tableau. Custom color can be added in Tableau by making use of preferences.tps. So go to my documents, go to my table repository, and you will find a file called as preferences.tps. And here, you can add a color code. You can add the hash code, which is also called as the custom color code, wherein you can add wherein you can add it and make use of it directly as well. But then one thing you have to note is that, let's say in Tableau version 9.0 and above, right, you have a direct color picker option, which is basically giving you a user interface to do the exact same thing. So all you have to do is you can click on the color that you require, hit OK, and you're done with it in a very simple way as well. So coming on to the 31st question, it states how can we combine a database and the flat file data in Tableau Desktop? How can we do this? It's again not a very difficult concept. All you have to do is you have to connect the data twice, because for the first time when you're connecting, it's for the database tables, and the second time you're connecting, it'll be for the flat file data. And then go to data, edit relationships, and give a join condition based on all of the columns that you have to find in common from our database file to the actual flat file data as well. So it's simple, connect it twice, once for database, once for flat file data. Go to data, edit relationships, put a join condition on the columns for the database tables to the flat file as well. And as soon as you're done with this, you have combined a database and a flat file in a very simple way in Tableau Desktop. Now, moving to the 32nd question, it states, what does Tableau do? Well, here's another tricky question, right? So Tableau can do a lot of things. Use the insights from all the 31 questions that you have come across until now to answer it. But then one important thing you really have to state is that Tableau is one of these tools which has a goal to make sure that it will help people see and understand data better, in a very aesthetic way and in a very simple way as well. So Tableau brings about a data analytics solution, it brings about a business intelligence solution and a data visualization solution. It puts it right in the hands of common people, right? So what it does is you will have a broad population of business users who can actually work with their data, ask questions on their data, understand the performance of their data, and eventually solve a lot of problems using this as well. So this question you can talk about 20-25 minutes and still you can have a lot of points that you can talk about Tableau as well. But then make sure to mention all the primary concepts. So make sure to mention all the primary points and how it adds value to the people, right? So what we're trying to do with Tableau is solve a problem. So make sure you talk about what the problem is and how Tableau aims to solve it. Moving to the 33rd question, it states, what is Tableau Public? Tableau Public is a free tool. It's a free service that lets anyone anywhere in the world publish an interactive data set onto the website, right? So once you're connected to the internet, you can do a lot of things. Once you have installed Tableau Public, I still say the same thing. You can do a lot of things. Now, whenever you think about making use of Tableau Public, make sure to explicitly mention that you really do not require any programming skills out here, right? So there's a lot of people, a lot of learners who keep asking us in case if they require a programming head start to start with Tableau. The answer is no, you really do not require anything, right? So with Tableau Desktop, anywhere anyone on the web can interact with the data, see the data, work with it, download it, create their own visualization, edit the visualization, and in fact, you can also check out what everyone else are doing as well. So you can do that to get ideas. You can do that to see how aesthetically pleasing things can get if something is done in a neat way when you're making use of Tableau as well. So it adds a lot of value, and make sure to mention all of that. Now with question number 34, we're talking about data modeling. So what is data modeling? One thing you have to know about data modeling is that it is the basic analysis that we perform of all of the data objects that we're using, in our context right now. So whenever we're trying to model data, we are trying to find relationships. We are trying to associate each of these data objects, comparing them one with the other to see how we can base any assumption on them, or how we can apply, certain steps on them to see how we can drive insight, right? So it's a pretty simple thing. To analyze the data objects, you really require context, you really require certain relationships to work with, and data modeling is a way that we can data modeling is a way where we go on to show all of these relationships as well. It is as simple as that. Moving to question number 35, it states, what is your daily process with Tableau? What is your daily work process with Tableau? This is another tricky question, and this is completely based on your way to work with Tableau. There is no one right answer for this. And start your answer with this, right? It completely depends on what projects you're working with Tableau, the complexity of the project, the client requirement, the performance requirements, the complexity of the actual time involved in doing the project, and a lot of other things. But then, of course, you can have a very simple data work process that I've mentioned on the screen. It's an example. So what usually happens whenever you're working with Tableau is that first you will get an understanding of what the requirements are, and after you understood what the requirements are, you're going to start pulling in all the required data. You're going to create a storyboard based upon that, and eventually apply and create visualizations in Tableau. And the last step, of course, you're going to present it to a client for review, right? So use this as a foundation, and you can talk about your previous experiences on this as well. So use all of these as foundational points, add more value to them based on the experience level that you have, and convey it to the interviewer in a clean and a concise way. Then coming to the next question, it states, how does Tableau work with big data sets or huge data sets? To start off the answer to this question, make sure to state this. Tableau's performance varies a lot depending on the performance of source data as well. So depending on how clean the data is, how structured it is, or a lot of other parameters that is present in the data set as well. So your performance is having a direct correlation with the performance of the data source itself. So what happens is that the main impact on performance comes whenever we talk about the time that takes to execute a query, right? So if your data source is taking an ample amount of time to execute a query, then what does Tableau have to do? Well, Tableau has to sit and wait until your data source can give you this data, right? So that means you are waiting, Tableau is waiting, and your data source is taking some time. So this really doesn't add a lot of value. So you can state all of these to say how Tableau can deal with huge data sets as well. It can do it very well, of course, but then it takes certain time to go on to do it. Now, coming to the next question, it states, how will you publish and schedule a workbook in Tableau server? It's a very simple task. All you have to do is create a schedule for a particular time, whatever time that is you require, and or let's say even the client has provided you a time. All you have to do is create an extract for the data source, pull all the data, and eventually publish it on the workbook in the server as well. So creating extract is the actual important step that you have to concentrate on, as whenever we talk about publishing a workbook, especially while scheduling it, right? So there's a lot of authentication methodologies that you have to check as well. So before you can publish it, there is actually an explicit option that states scheduling and authentication. You can click on that, you can select the schedule from whenever you have to publish it, and then directly hit publish. So all the data sources and all of the assignments that have to be published will run through the schedule and be done automatically without you having to put a lot of time, or let's say punching back in whenever you have the scheduled time and then looking at something there as well. So you really don't have to do any of that. This entire process is automated. It will get refreshed on a regular basis, and you can work with it automatically without having to put much effort as it is. Now, coming on to the 38th question, it states, distinguish between parameters and filters. Well, parameters, you already have to know this. It is the dynamic values that will replace all of the constant values whenever we talk about any calculations, right? And parameters, if used right, can be used as filters itself. But what are filters? Filters are used to restrict the data based upon conditions that we have, and wherever we mentioned all of these conditions, we have mentioned it in the filters shelf, right? So it's a very simple thing. Talk about what filters are, talk about what parameters are, and make sure to state that you can also use parameters as filters if required as well. So that point is a highlight, and it'll add a lot of value if you can state that directly too. And now coming on to the 39th question, it states how to view an SQL generated query in Tableau Desktop or by Tableau Desktop. So all of the queries that get generated actually go into a log file, right? So there's the Tableau or desktop log file. So there's the Tableau desktop log file that you can get into as soon as you go into C drive, users, my documents, my Tableau repository.
Just a quick info, guys. Test your knowledge of Tableau by answering this question. Which of the following is not a trend line model? A. Linear trend line. B. Exponential trend line. C. Binomial trend line. D. Logarithmic trend line. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Is where all of your data is mentioned, all of the detailed information about the query. So make sure to mention all of these as well. Once you have to have a live connection with the data source, you have to check all of the files. If you're making use of an extract, there's another file, and the actual file which will contain all of the queries as well. Now moving on to the 40th question, it states what is page shelf? Page shelf is a very simple concept, but do not be fooled by how simple it is, because it's a very powerful part of Tableau. It's a foundational concept in Tableau where you can actually control the display of the output and any result that gets printed on the output as well. So page shelf acts as a primary barrier, acts as a primary visualization criteria where you can work with a lot of things to make sure that you can control a lot of parameters when displaying or when controlling the output as well. So in that regard, page shelf adds a lot of value. Now, coming to the 41st question, we have another different question. So moving on to the 41st question, we have a question that states, what are the major differences in between Tableau 7 and Tableau 8? Now guys, you really have to know this question. This is another trick question that can be asked to you to see how proficient you are with Tableau and all of the years of experience that you say you bring with, right? This is a way to verify that as well. So, with respect to Tableau 8, you have a lot of new things that got implemented. Think about tree maps, think about bubble charts, think about whisker plots, box plots, and all of that, right? So new features are amazing. One very important thing you have to talk about is the introduction of the R script and how you can directly copy the worksheet from one workbook into another one without having to redo it or without having to put in a lot of effort there as well. So not only this question, whenever you asked about any question pertaining to older version of Tableaus, in case if you have used it, I'm sure you'll be able to answer those questions. But then in case if you haven't used it, make sure to explicitly mention saying that you haven't had a lot of experience using that as well. I mean, of course, it's going to be 90% same with one version to the other, but then it always adds value if you know it exactly as well. So make sure to mention that. Moving on to question number 42, it states how to create filled maps. So to create a filled map, right, let's take an example. Whenever we talk about map view, right, so all you have to do is click on the geographical field, click on anything such as zip code, click on area code, state, or any of these, and select the filled map mark type, right? And select the filled map mark type. So with this, what you can do is the automatic mark type that will show all of the types of views as circles over the map, right? So once it starts showing it as circles over the map, then you can have the marks card, and from the marks card you can select all the filled map to eventually color your geographical areas as per requirement as well. And to color all of that, it's a very simple thing, and I'm sure you already know this. And step number 3 is very simple. Drag a field to the color shelf, define what locations need to be colored, how these locations need to be colored, and just drag a field to the color shelf and you can be done with that. And of course, you can explain this probably in under a minute to the interviewer, but then if you have your laptop, I would really suggest you take your laptops to the interviewers in case if that's allowed, and then make sure to show this practically to the interviewer as well, because all of these concepts you can explain them easily and in a very straightforward way verbally, but then what will add value is if you can actually show them practically as well. Now moving on to the 43rd question, it states, does a parameter have its own drop down list? In Tableau, yes, a parameter has its own drop down list, and whatever entries that you make in the parameter while actually creating, right, so it can be directly viewed as items in the drop down list. So the answer is simple, the answer is straightforward. It's a yes, it's possible to have a drop down list for a parameter. Moving on to the 44th question, it states, how is data blending different from data joining? Again, this is a question which is asked a lot of times in this interview, just like all of these other questions that you've been going across right now. So make sure to concentrate. Now, when we talk about data blending, right? So data blending, as the name suggests, in fact, is the process where we combine the data from two different sources or more than two different sources as well. So, your two different sources can be a Microsoft Excel file. You can have another set of data on an SQL server, Oracle server, a cloud computing platform, or a server which is on premises, a remote server which is in the client's location, and a lot of other things to bring these data together to use in Tableau, right? That's what data blending is. And data joining, on the other hand, is a very simple concept. It's a straightforward concept, just like data blending, but it's very different. What we're trying to do here is we're trying to combine the data from two or more tables and sheets from the same data source. Data blending spoke about two different data sources and bringing it together. Data joining is all about talking about two different sheets or tables that are present in the same data source, guys. That is the basic difference. In joining, we talk about same data source and everything that is present in that data source, and in blending, we talk about more than one source. So make sure to explicitly mention that without fail. And now, question number 45, it says, is it possible to store a huge amount of data in the memory engine by making use of Tableau? Is it possible to store a huge amount of data? If yes, how can we do it? So if an interviewer asks you a question like this, right, the second part of the question might give you a clue to the first part in case if you're unprepared as well. So he or she can state, if yes, how is it possible, right? So the actual answer to this question, now coming to that, is yes, it is possible to store a large amount of data in the memory engine by making use of Tableau. But then it is not as simple as that, because there is no one straight answer to this, because you can store massive amounts of data based upon the Tableau server implementation. You can have a lot of configurations for that, right? You can have 8 core configurations, you can have 16 core configurations, and you can have more than that as well. So depending on how your Tableau server is configured and built, based on that you can store it. So it's a relative answer to the relative question. And not only if just hyper is used or not, let's say there are many other factors that will affect, such as the server memory can also have an exponential effect in how much data that you can eventually store and directly use in a rapid fashion for the memory engine, and a lot of things as well. So make sure to talk about the server memory and make sure to talk about the server configuration in general as well. Now, moving on to the 46th question, it states, what is the difference between rank and index in Tableau? So whenever we talk about rank and index, one commonality is that both of these come under table calculations in Tableau, guys. So index is the actual entity that will deal with the record's physical location, and think about incremental numbers, for example. So as soon as incremental numbers are assigned according to the record's physical order, right? So as soon as this order is particularly met, and how is it met? By making use of index. Now, whenever you think about rank, right? So rank usually deals with the record's value. Whatever highest value is there gets the highest rank. Whatever lowest value is there gets the lowest rank. So it's a pretty simple and a straightforward business in terms of rank and index as well. Index deals with its position, record deals with its values, right? So if you have used any other programming language as well, you will understand the usage of index. And rank, as the name suggests, is a numerical value that denotes how it maps in the real world as well. Now with that, coming to the 47th question, here is another very simple question, but then if you do not know how to answer this, it can get a little difficult as well. So to answer this question that states, suppose my license expires today, can my users be able to view the dashboards or workbooks that I published in the server earlier? Well, you really have to know the answer to this question, guys. If your license expires today, right? If your server license expires today, the username of the server will change. It'll go from the name that you have put in, and it'll say unlicensed user. It means that whoever created the dashboard and published it into the server cannot access it anymore. But then everyone else can still do it. So the site admin, what he can do is he can change the ownership to another person, and So at this time, what the site admin can do is the site admin can change ownership to another person. This way, we are trying to make sure that if we have and if we are making use of extracts, right, it doesn't fail. But if you do not change ownerships, you really cannot extract the data anymore if it's unlicensed. So yes, if the license expired today, you cannot have access to it, but then everyone else can. Moving on to the 48th question, it states, what is the difference between the quick filter and the normal filter in Tableau? Well, quick filter is an entity that's used to filter options and to select options in a very rapid manner. And a normal filter is something with which you can limit the options from the list. You can calculate some conditions, work with the data, limit it based upon a value, limit it based upon an index, or limit it based upon a general field in a column as well. So quick filter is used to view the filtering options, while normal filter is actually used to view a lot more compared to that as well. And hence the name quick filter and normal filter in Tableau. So make sure to mention this basic difference in a clear way to the interviewer. Moving on to the 49th question, it states, what is your plan after joining for the Tableau developer role, or let's say any other Tableau role that you might be joining for as well? So to answer this question, make sure that you keep it concise, you keep it clear, and do not talk about it for 20 minutes. So you can start answering on how you have actually worked with Tableau in your previous years. It may be your learning, it may be your it may be your use in a production environment and whatnot. And think about talking about a plan where you first understand the company structure that you're interviewing for, and how well you can have an impact in terms of Tableau will only come if you can understand how well the data is implemented there, right? How the data workflow is set up, how the infrastructure is set up, and all of that. So talk about you first having the ability to easily grasp and understand new things, and then talk about how you can better it or improvise something in the coming days with further iterations as well. It's not only just that, right? So it's all about you fitting into a role, being a team player, the ability to talk to multiple teams, and the ability to solve the problem at hand. And if you can do it very efficiently as a Tableau developer, then you open up your resume not only to just one or two interviewers, but then even to the top companies across the globe as well. So this is a very tricky question. This totally depends on your potential, your capability, but guys, it is extremely vital, as I've highlighted in the answer, that you have to keep it concise and you have to talk about how you will fit in there, right? So you really cannot barge in and say, I'm going to start changing everything up. Yes, you might have to start changing everything up only after you have understood it and you've seen a problem and you have a thorough way of solving that with your solution, which is supposedly better as well. So make sure to mention all of that. Now, coming to the last question, it states, have you earned any sort of certification to improve your learning and implementation process? Well, guys, if you've made it to this question, congratulations. These 50 questions will add a lot of value to your Tableau interview, and I'm sure you can use this as a guide to ace all of your interviews as well. But then this question is very important. If you have ever used a certification program to learn and gain knowledge, you will understand that it will portray a lot of things, right? So you can gain a lot of knowledge in a clear way, in a concise way, from professionals across the globe, and you can make use of real world projects to concrete your learning, and you can do a lot more for a learner. But now let's talk about what it does whenever you're in an interview, right? So if you have certifications, let's say you are a certified Tableau developer, as soon as you step into this Tableau interview and you state that you have a certification and you talk about it, one thing it will show to the interviewer is that you want your career to be built around here, right? So because you would have spent a considerable amount of time, you would have spent a considerable amount of effort to go on to do something in this field as well. So in that aspect, you definitely will show a lot of aspiration there too. And another thing where you're showing strong aspiration is, let's say if you've jumped from another different background, you might be coming from a management background, you might be a Python developer who wants to become a Tableau developer now, and everything else too. So it'll show that you have the ability to grasp novel things, new things, and understand how they work. And you being serious about it also shows how your certification has added value to your life as well. And of course, since you'll be learning a new thing, in case if it was new to you, not taught in college or any of that, it will show that you are an effective learner and you have the capabilities to be taught. So being teachable is everything in today's world, and I'm sure most of you already know that as well. So one important thing you have to talk about is, of course, yeah, talk about the certifications, talk about what you learned through that certifications. But then here's a secret, guys. Here's a secret tip. Talk about how you used it rather than talking a lot about what it is, because there's a good chance they already know. So there's a good chance that the interviewer might know all the certifications that already exist with Tableau, but then he or she will absolutely have no clue what you have implemented, right? So talk about your projects, talk about your ideas, talk about the new things that you have tried, talk about your practical implementations that you have done after your learning. This is where you try to understand, and this is where you actually impress the interviewer as well, guys. So I hope these 50 questions add a lot of value to your interviewers, and I take this opportunity to wish you all the best for all the upcoming interviews as well. As always, I'll see you on the next one.
Just a quick info, guys. Intellipaat provides Tableau online training and certification course mentored by industry experts. The course link of which is given in the description below.